In Utah, there's a massive jagged scar in the earth slicing through the landscape like a knife through a cake. And here's the weird part. You've probably never heard of it. No breaking news banners, no police tape fluttering in the wind, no black helicopters circling overhead. A crack this huge appears out of nowhere, literally tearing the desert apart, and the world just kind of shrugged. How is that even possible? Why is something this dramatic getting the silent treatment? To solve this mystery, we need to dig deep, literally. Let's zoom in on the scene of the crime. This isn't a clean, straight line you'd see on a map. It's messy, it's chaotic. In some spots, the walls drop straight into pitch blackness. In others, the edges have crumbled, so getting close feels risky. The crack dominates the view, yet it's hiding in plain sight. The experts over at the Utah Geological Survey aren't totally clueless though. They have a theory. It's a concept that sounds boring on paper. Subsidence. But trust me, the reality is terrifying. Think of it this way. Don't picture the ground as a solid block of stone. Think of it like a wet bath sponge. Down below you have aquifers, layers of soil and sand holding water. That water acts like a support beam. It pushes out against the dirt and holds the ground up. But here's the catch. We are thirsty. Agriculture, cities, industry, we're sticking giant straws into the earth and slurping that water up like a milkshake. So what happens to a wet sponge when you squeeze it dry? It shrinks. It gets brittle. That is exactly what's happening in Utah. We drain the water, the support vanishes, and the soil collapses on itself. Gravity wins. The floor literally gives out because it's empty inside. That's the leading theory. We dehydrated the ground until it snapped. But hold on, if it's just about water, why does this look so dramatic? This isn't just a gentle dip in the road. This is where the experts point to the mechanics of the disaster. When the ground subsides, it doesn't always go down evenly. Deep underground, you have ridges of solid bedrock buried beneath the soil. When the soft soil sinks, it drapes over these hard ridges like a wet blanket over a sharp fence post. The tension builds up until snap. The earth tears open from the bottom up. This creates deep vertical fissures that can stretch for miles, and unlike earthquakes, which give you a rumble, these things are dangerously silent. One day the field is flat, and the next morning there's a gash deep enough to swallow a tractor. So, here's the million-dollar question. If this is caused by us draining the aquifers, why isn't it a national emergency? Why aren't sirens wailing? 2 words: location and money. Most of these fissures in Utah, like the ones in Cedar Valley and Parowan, tear open in rural areas. They appear in alfalfa fields, remote scrublands, or near dusty service roads. They aren't threatening a skyscraper in downtown Salt Lake City. Yet. In the real world, out of sight means out of mind. Since these cracks mostly annoy farmers and damage irrigation pipes, they don't make headline news. The crack just sits there, growing, waiting. For the locals who live near them, these fissures aren't a viral internet mystery or a tourist attraction. They're a practical nightmare. Farmers view them with dread, not because of superstition, but because they're dangerous. Livestock can fall in. Farm equipment can be destroyed. There's no riding dirt bikes into the abyss here. These are unstable, crumbling scars on private land that represent a livelihood literally falling apart. But there's a tension there. Experts know the uncomfortable truth. If a fissure like the one in Enoch, Utah, opened up 50 miles away under a newly built suburb, we wouldn't be ignoring it. We'd be calling it a catastrophe. And that's the scary part. We treat these cracks like weird roadside attractions, but they're actually warning shots. This isn't just a Utah problem, it's a global one. We've seen what happens when we ignore the ground beneath us. And yes, it happened before, and you may remember. Guatemala City in 2010? People heard strange sounds for weeks. Then suddenly, a nightmare. A perfectly circular hole 60 feet wide, 300 feet deep, opened up downtown. It swallowed a 3-story factory whole. It looked like a portal to the underworld just popped open at an intersection. That wasn't an earthquake. That was soil failure. Or take the horror story from Florida in 2013. A man named Jeff Bush was asleep in his bed, safe at home. In the middle of the night, a sinkhole opened up directly under his room. The floor just vanished. His brother heard a scream and ran in, but Jeff was gone. The earth had taken him, and he didn't survive. The house was demolished, the lot fenced off, and that was it. Nature took its space back. Then you look at China, where aggressive mining and water reduction have created cracks that make the Utah thing look small and funny. Entire neighborhoods are split in half, bridges collapse, fields are sliced open. And this isn't another science fiction story. This is the reality of living on a planet that we are actively destabilizing. The crack in Utah is trying to tell us something. We just need to listen to it carefully. It's a giant dusty bill coming due. We treated the ground like an infinite bank account, and now the check has bounced. Needless to say, the system is stressed. We build on it, drill into it, drain it, and assume it will just take it. But even the Earth has a breaking point. What keeps scientists awake at night isn't necessarily this specific crack in the desert. It's what comes next. These things like to spread. Today, it's the desert. Tomorrow, maybe a highway. Next year, why not the foundation of a new housing development? And it's not just about a hole in the ground, it's about what runs through the ground. Fiber optic cables, gas mains, sewage lines. When the Earth shifts even a few inches, those pipes snap. We're talking about billions of dollars in infrastructure damage that happens in slow motion. You don't see the disaster until your basement floods or the road buckles under your tires. And here's the kicker. Soil compaction doesn't heal. You can't just pump water back in and inflate the ground like a balloon. Once that structure collapses, it's game over. The land sinks permanently. The cracks are scars that stay forever. So why should you care about a hole in Utah? Because it's a canary in the coal mine. It's a visual representation of the damage we are doing, invisible to the unaided eye until it's too late. The silence surrounding this phenomenon is the most dangerous part of it. It suggests that if we don't look at the problem, it doesn't exist. But gravity works whether you're watching or not. The Utah crack is a monument to the unseen forces shaping our world. It challenges us to look down and ask, what exactly are we standing on? The Earth is tearing open, and it would be very, very wise to stop ignoring it.
Kilauea, one of the most active volcanoes in the world, erupted again in March 2026 on Hawaii's Big Island. Huge lava fountains shot into the sky. The main highway was closed, and the airport was blocked by sandpaper clouds of ash. The sky turned a creepy deep red. That's how thick the smoke was. The eruption literally closed some areas of the island. It was already the second time this year. The eruption happened right inside the Halemu'umu'u crater at the volcano summit. Things got dangerous fast, and visitors had to evacuate the volcano summit. The lava fountain shot straight up about 1,300 feet. That's almost as tall as the Empire State Building or higher than the Eiffel Tower. But let's watch the eruption unfold step by step. It started on March 10, 2026, and lasted about 9 hours, ending suddenly at 6:21 p.m. The eruption started in the morning at 9:17, with lava shooting up from the north vent. As for the south vent, it started erupting just before 10 a.m. By early afternoon, the lava fountains were huge. The south vent reached 1,150 feet high, and the north vent was 1,000 feet. The lava was flowing across about 1/3 of the crater floor, glowing bright orange and red. As the lava cooled in the air, it turned into something called tephra. That's a mix of volcanic rock, ash, and tiny glassy shards. Tephra can scratch your skin like sandpaper, making your eyes sting and making it hard to breathe. Even worse, it can turn roads into skating rinks for cars. Because all of this, part of Highway 11 was closed between mile markers 24 and 40. Back in January, during another eruption, it also rained tephra over the park and nearby towns. Some unlucky visitors actually got hit by falling tephra, and a few even got cuts. The Park Service had to close the summit for the first time since its eruption cycle began on December 23, 2024. Now, the National Weather Service says the eruption plume reached 25,000 feet high. That's nearly 5 miles straight up, higher than most airplanes fly. Winds were blowing from the south, so ash and gas started moving north from Halima'uma'u. Officials warned people in nearby cities to stay indoors or leave if the gases began to bother them. Now, this eruption wasn't the first trouble Kilauea caused this year. An earlier one started on February 15th and lasted almost 10 hours. During that eruption, lava covered half of the crater floor. Scientists estimate that 15 million cubic yards of lava came out. That's enough to fill thousands of swimming pools or cover hundreds of football fields. At 2 p.m. on March 10th, tephra was still falling. Park rangers helped evacuate visitors from the summit. All trails and viewing spots near the summit were closed. Scientists are keeping an eye on things all day and night, watching how high the lava shoots, how fast it flows, which way the ash cloud is moving, and where the fallout spreads. Even though the lava mostly stays in the crater, tephra and volcanic gases can make living near a volcano pretty risky. Since December 24, 2024, Kilauea has been spitting lava on and off, mostly from 2 vents at the summit crater, one to the north, one to the south. Eruptions happen in short bursts, usually less than half a day. After that, the volcano takes a break for a while. Could we say the volcano is chilling? No, we can't. Sometimes those pauses can last 2 weeks or more, as if giving the lava time to catch its breath before the next show. But let's talk a little bit more about tephra. The biggest problem is that it doesn't just stay near the volcano. In past eruptions, it rained down on neighborhoods as far away as Hilo and Puna, messing up water systems and creating a huge cleanup job. At Hilo International Airport, all evening flights were canceled because of ash in the air. And for weeks afterward, locals and park staff were sweeping tephra off roofs, gutters, streets, just about everywhere you can imagine. According to the park spokesman, the reason tephra spread so far is a mix of weak winds and extremely tall lava fountains. When that happens, the volcanic debris drops straight down over the park and nearby towns. During past eruptions, steady winds, called trade winds, which usually blow from east to west across the islands, acted like a conveyor belt. They carried ash and volcanic gases over the Cow Desert and nearby towns to the southwest. Another super dangerous thing about an eruption is glass rain, also called Pele's hair. It's a kind of tephra that happens especially when lava fountains shoot up really fast. Tiny gas bubbles in the lava burst and stretch the molten rock into super thin, fragile strands. The wind then carries them far away. This stuff is lightweight but brittle, so it can scratch your skin or get in your eyes or lungs. The name comes from Pele, the Hawaiian goddess of fire and volcanoes, because it's kind of born straight from volcanic activity. During big eruptions, like the one in 2018, these strands were reported falling all around the volcano. Now, Kilauea isn't the only threat in the region. The sleeping giant next door, Mauna Loa, got an update from scientists on March 5, 2016. The volcano isn't erupting yet, but it's inflating as magma fills its huge underground chambers. You might think of it like Earth taking a deep breath. But it isn't just breathing. In the past month alone, over 100 earthquakes have been detected under the summit. Should we get worried? Well, let's figure it out. Mauna Loa, the largest active volcano on Earth, covers half of Hawaii's Big Island. Its eruptions can produce huge, fast-moving rivers of lava, like a slow-mo bulldozer made of molten rock moving across the area. When Mauna Loa erupts, it usually starts at the summit. From there, lava can flow into different areas: the Northeast Rift Zone, Southwest Rift Zone, or even vents on the northwest side of the volcano. The most intriguing thing is that these lava flows can appear within minutes, hours, or even months after the eruption begins. Since its first well-recorded eruption in 1843, Mauna Loa has erupted 34 times. The gaps between eruptions can range from just months to many decades. Its most recent eruption was in 2022. Right now, Mauna Loa is quiet but active. Seismic activity, that is, small earthquakes under the volcano, shows that magma is, in fact, moving beneath the surface. In February 2026, scientists detected 116 earthquakes beneath the summit, mostly gathered under the caldera era called Makuaweo Veo. Some were also concentrated in the southern caldera. But don't let this number scare you. For comparison, the month before had 123 earthquakes. The thing is, these quakes are part of the normal breathing of the volcano as it refills with magma after the 2022 eruption. GPS instruments on the volcano indeed show that the summit is inflating, meaning the ground is slowly rising as magma fills the underground reservoir. At the same time, gas and temperature readings from the southwest rift zone are at normal levels, which means no major changes compared to previous months. So even though Mauna Loa is refilling, there's no immediate sign of a new eruption, yet. In any case, Mauna Loa is always worth watching. It's a sleeping giant that can wake at any time, and scientists are keeping a close eye on every inch of rising ground. Because if Mauna Loa erupts, it can cause a ton of different problems. Massive rivers of lava can flow quickly and cover land in their path. The volcano itself can also make the ground shake, because as magma fills it, the sides of the mountain can shift up or sideways, triggering earthquakes. On top of that, Mauna Loa can release volcanic gases that mix with the air and create fog, a kind of smog that can be irritating or even make it hard to breathe for people living downwind. Sometimes, the volcano might even produce small explosions, sending ash into the sky, which can be dangerous for airplanes flying nearby. Around our planet, there's an invisible magnetic shield that blocks solar radiation. But it isn't spread evenly. One patch is thinner and it has a name: the South Atlantic Anomaly. On the ground, we're fine. Up in orbit, satellites get glitchy as they fly through charged particle storms. And lately, that weak spot looks like it's changing shape. It's spreading out, and some maps even show it splitting into two. So why is that happening and what does it mean? Well, to understand the weak spot, we have to go deep below to the core of the issue and the planet. Around 1,800 miles down, Earth's outer core is a boiling ocean of molten iron and nickel. There, the temperature can rise to more than 10,000 degrees Fahrenheit. As that liquid metal moves, it generates electric currents, and those currents create our magnetic field. Now, without the field, the sun's charged particles would slam straight into our atmosphere and start stripping it away. But this magnetic field isn't a smooth, perfect bubble. It's lopsided and tilted. It's constantly shifting. Beneath Africa, some magnetic lines bend the wrong way, back toward Earth instead of out into space. Scientists call these reverse flux patches, and they weaken the field above them. Right over that weak spot is the SAA, the South Atlantic Anomaly I mentioned earlier, and it's changing fast enough that we can watch it shift over just a decade. Scientists know this because of an ESA mission called SWARM. It's 3 satellites constantly, swarming, and mapping Earth's magnetic field in detail. Their maps show that the anomaly has been spreading since the mid-2010s. It's getting weaker and starting to look like it's splitting in two. Now, back down here, we're protected by the atmosphere, but we are still affected indirectly if satellites start acting weird. Most of the satellites we rely on are in low Earth orbit, a few hundred miles up. Over the SAA, the radiation belts droop closer to Earth than usual, so when a satellite passes through, it's like driving through a stretch of space that's far more charged than normal. A single burst of particles can flip tiny bits inside a computer chip. It can corrupt a sensor for a moment or trigger a reset. It can force the satellite into safe mode, where it shuts down anything sensitive to survive. Many satellites cross the SAA multiple times a day, which means each pass is another roll of the dice. Even Hubble has to respect it. Hubble is one of the most famous space telescopes that's been taking those insanely sharp pictures of galaxies, nebula, and weird deep space stuff for decades. But when it's about to fly through the South Atlantic Anomaly, it basically goes, no. It stops certain observations and shuts down its most sensitive detectors until it's in the clear again. The satellite is too valuable, and it's not worth taking chances and losing it. Which is exactly what happened to a high-tech Japanese satellite. In 2016, Japan launched Hitomi, a next-gen X-ray space telescope built to study the hottest and craziest objects in the universe, stuff like exploding stars and monster black holes. It was supposed to run for years. Instead, a problem that showed up when it was passing through the SAA kicked off a cascade of attitude control failures. The spacecraft ended up spinning, breaking apart, and the whole mission was lost just weeks after launch. That's not a glitch. That's a multi-year science plan worth billions of dollars lost in just a month. So why does SAA seem to be growing, and why would it split into two? Deep under Africa, Earth's core is like a giant pot of liquid metal. The swirls can change shape over time. Imagine you're holding a strong magnet under a table, and on top of the table there's a thin metal sheet. If you slide the magnet around underneath, the metal above shifts too. If you use one magnet, you get one dent. If you move it or add another magnet nearby, the dent stretches or splits into two. The moving liquid iron deep below acts like shifting magnets. When the flow pattern changes, it creates weak spots in the magnetic field. If one weak spot spreads underground, the dip above it spreads too. If two weak spots form close to each other, that single sag at the surface can split into two dents right next to each other. And that's where this stops being cool Earth science and starts being a problem. Because if the magnetic field can rearrange itself that much in a decade, well, anything we rely on in orbit has to deal with it. But is the South Atlantic Anomaly just one local weak spot we have to work around? Or could it be an early hint of something much bigger, like a pole reversal? You see, Earth's magnetic poles are not locked in place forever. North and South have swapped many times before. Magnetic North can drift, weaken, and eventually trade places with magnetic South. Wait, what does that actually mean? Well, it means those football fans who are gathering in the North Stand now have to start cheering from across. But, jokes aside, the planet is not flipping around or becoming the upside-down world. The liquid iron shifts its flow pattern, and the whole magnetic layout reshuffles. Just like every other natural process, it doesn't happen all of a sudden. The field can weaken first, it can break into uneven patches, it can look messy for a while before it settles again. That problematic stage is what would matter most for satellites. Because we know this happened before. When hot lava cools into rock, tiny bits of metal inside line up with Earth's magnetic field and get stuck pointing that same way. Much later, scientists can read that direction like a compass arrow trapped in stone. One famous case is the Lachamps event about 41,000 years ago. Hey, I wasn't around then. But for a while, Earth's magnetic field got much weaker. Then it partly flipped, and then it bounced back. The simplest idea is that the liquid iron deep inside Earth started flowing in a different, unpredictable way for a while. So the magnetic field got scrambled. A pole reversal is the biggest version of this scramble. The South Atlantic Anomaly is a smaller, local version. Both happen because the liquid iron flow deep inside can change. The SAA does not mean a reversal is definitely coming. It just shows the magnetic field can get uneven when the stuff underneath shifts. While the anomaly is changing, there's another space problem that can hit way beyond that one spot in the Atlantic: geomagnetic storms. The Sun sometimes launches a huge cloud of superhot gas with its own magnetic field. It's called a coronal mass ejection, or CME. Some of these clouds race outward at over 1 million miles per hour. If one of them is aimed at Earth, it slams into our magnetic shield and shakes it. That shaking dumps extra energy into the space around Earth. It scrambles radio signals, messes with GPS accuracy for a while, and, in extreme cases, even pushes electric currents into long power lines on the ground. Oh, and they also cause breathtaking auroras. Back in March 1989, a major geomagnetic storm triggered a Quebec blackout that left 6 million people in the dark for hours. Another example was in May 2024, when a strong geomagnetic storm disrupted certain satellite and radio signals, forced some airlines to adjust routes, and pushed auroras much farther south than usual. Solar storms don't hit at the same strength all the time. The sun goes through an activity cycle that lasts about 11 years. During the busiest phase, it fires off more flares and more giant clouds of charged particles, so strong geomagnetic storms become more likely. Right now, we're in one of those busier stretches. So the odds of rough space weather are higher than they were a few years ago. But the bigger reason it feels scarier is how modern life works. We lean on satellites and power grids more than ever. So a storm that used to be a cool aurora night can now mean signal glitches, GPS hiccups, rerouted flights, grid strain, and a lot of expensive fixing.
If you think you're safe from violent tornadoes because you aren't living in the tornado alley, you could be dangerously wrong. It's shifting to the east. It looks like we're about to see fewer single tornado days and more days with multiple powerful tornadoes. And because they're shifting into more populated areas, they could take more lives and ruin more homes. There isn't enough time to build infrastructure to protect everyone from this fast-moving danger. So the least you can do to save yourself is learn as much as you can about it. About 1,200 tornadoes hit the US every year. You gotta thank the unique geography that sets up the perfect conditions for it, especially in spring and summer. Winds from the Pacific drop moisture over the Rockies and become dry and cool as they move east. They collide with warm, humid air streams from the Gulf of Mexico over the flat terrain. And that's how unstable air and wind shear, which are the perfect conditions for tornadoes, are born. Historically, tornadoes were most common in Tornado Alley. This term was first used in the 1950s by two meteorologists as the title for their research project to study extreme weather in Texas and Oklahoma. Northeastern Texas and south-central Oklahoma are precisely the areas we think of when we talk about Tornado Alley. But in the past 10 years or so, it has shifted eastward by up to 500 miles. Now, eastern Missouri, Arkansas, western Tennessee, Kentucky, northern Mississippi, and Alabama see more tornadoes. The storms of early 2023 are great proof that this trend is real. A violent tornado hit Rolling Fork, Mississippi, and another outbreak caused huge damage in the new Tornado Alley. Data from the past 2 years shows that large tornado outbreaks with multiple twisters from a single weather system are also moving eastward and becoming more frequent and intense. The Tornado Alley is shifting eastward mainly because of supercells. Those strong thunderstorms with rotating updrafts create new tornadoes. Supercells form when warm, humid air near the ground interacts with cool, dry air higher up. You can say that we're living in the middle of a natural experiment. We see changes in the basic ingredients for severe storms. But we don't know how significant these changes are. Experts predict that supercell storms will become more frequent in the late winter and early spring and less common in the late summer and fall. The air in recent years is getting warmer and moister, and the interactions between air masses more and more common. Experts explain that the atmosphere is becoming more unstable and the Gulf of Mexico sends more water vapor into the southeastern U.S. All these factors fuel the storms. Research also shows that the so-called dry line, which divides the wetter eastern U.S. from the drier western U.S., is shifting eastward too. This line has traditionally fallen along the 100th meridian, but has moved about 140 miles east since the late 1800s. This shift can affect where storms form, as the dry line works as a boundary for convection, where warm air rises and cold air sinks, fueling storms. Milder winters we've seen recently also mean more opportunities for unstable air masses to interact and form supercells earlier in the year. It's tricky to predict how the situation will change and how dangerous it is because we don't have that much data on how weather patterns affect such short-lived events as tornadoes. The U.S. National Weather Service only began keeping tornado records in 1950, and they didn't catch many tornadoes in remote areas. Data shows that the number of days with tornadoes each year has decreased, but there's more tornado activity on those days when they do occur. The records also show that some years, tornadoes take the lives of up to 20 people across the U.S., and in other years, they take over 100 lives. But now, there are more people living in the paths of tornadoes because the U.S. population has more than doubled since 1950. And the Southeast, where tornado activity could go up, has way more residents now. Texas and Oklahoma are well prepared with tornado shelters. But areas in the Southeast are less equipped. Plus, there are many mobile homes in the Southeast which are vulnerable to windstorms. Tornadoes in this region often strike at night, and they are 2.5 times more likely to cause fatalities. We could possibly have more events like the 2008 Super Tuesday tornado outbreak. It hit the southern U.S. and lower Ohio Valley, and over just 15 hours, 87 tornadoes rushed through the area and caused massive trouble. 57 people lost their lives across 4 states and 18 counties, and many others were injured. The tornadoes were fueled by strong low-pressure systems that brought record warmth. There were supercells and rotating winds that produced these violent tornadoes. Early on February 5th, a squall line developed from eastern Texas to Missouri and moved east. One of the most intense tornadoes traveled 122 miles over 2 hours. By the early morning of February 6th, the severe weather threat shifted to the eastern U.S. It caused wind damage as the cold moved out to the Atlantic with snow and freezing rain from Iowa to Quebec. It ruined many homes and even swept some of them from their foundation, made mobile homes fly, blew many vehicles and tractor trailers off Interstate 40, and threw some cars on trees. There were wind gusts over 50 miles an hour from Arkansas to Indiana, hail the size of softballs, toppled trees, and power outages everywhere. Some areas were flooded because of heavy rains and melting snow. All this led to over 1,000 flight cancellations at Chicago's O'Hare and disruptions at Toronto's airport. The data from scientists can help new areas of the U.S. prepare for more tornadoes coming their way. The people in authority will also need to improve community shelters and warning systems and educate the locals on tornado safety. You can also get prepared by learning 3 basic rules: get in, get down, and cover up. When you hear the warning for an upcoming tornado, get into the most interior room in your house and stay away from doors and windows. If you have a basement or an underground tornado shelter, hide there. If not, just be on the lowest floor possible. You can use whatever's at hand to protect yourself from debris. Clothing, pillows, blankets, a mattress, or a bulky table. Anything will do. There's a tip that says that the bathroom is the safest place to hide. It makes sense because those are mostly right in the center of homes. In March 2023, a man and his girlfriend in Rolling Fork, Mississippi survived a tornado in their bathtub. It got thrown into the air but landed safely amid the wreckage of their mobile home. But there's actually nothing extra safe about being in a bathtub with a mattress. Closets and walk-in showers that are deep inside the building can also offer good protection. Don't use elevators. You can get trapped inside if there's a power outage. Stay in your shelter until you're sure the tornado threat is over. If you can, listen for updates from the National Weather Service, local radio, or TV. Multiple tornadoes can hit the same area, so it might not be safe to leave even after one has passed. When you do leave your shelter, be very careful. There could be flooding, debris, collapsing buildings, and blocked roads. Stay away from fallen power lines and puddles with wires in them, and don't use matches or lighters in case of gas leaks. Stay away from damaged buildings as they could collapse at any time. Being in a car during a tornado isn't much safer than being out in the open or in a parking lot. Many people get injured trying to drive away from storms. Tornadoes can produce hailstones the size of softballs and can easily smash a windshield. If you find yourself outside when a tornado hits, try to get inside any building you can find. If that's not possible, get as low as you can. Even a ditch or culvert can be safer than your vehicle. Yellowstone is the internet's favorite doomsday volcano. Maybe you heard the prediction. One super eruption, then a continent dusted in ash and temperatures going down. A perfect disaster movie scenario. Yet, geologists worry about a different kind of volcano. One that won't explode only once. It could rip the ground open, flood the entire continent with lava, and make the air unbreathable. And we know this because it happened before. Right now, researchers think there might be around 20 supervolcanoes scattered across the planet. Short story, we fear those. Long story, a major supervolcanic eruption could collapse modern society as we know it. A normal volcano can cause a local disaster. It can wipe out a city and turn a region into a no-travel zone. When Mount St. Helens exploded in 1980, it was huge. The eruption blew the top off a mountain and flattened forests like knocking down dominoes. It showed the world just how scary volcanoes can be. But in geological terms, it's nowhere near what a supervolcano could do. Mount St. Helens threw out roughly a third of a cubic mile of ash, enough to make a football field pile about 150 miles high. For comparison, a supervolcano could bury the entire state of Texas 5 feet deep, and Texas stretches about 800 miles. Volcanoes like St. Helens are mountains that build up over time, layer after layer, like nature stacking spilled wax. They erupt, they cool, they erupt again, and you end up with a cone that looks cool in photos. A supervolcano is like a hidden pit. It resembles a giant underground tank of molten rock covered in a thick slab of crust. Imagine the magma chamber like a huge underground room, and the ground above it is the ceiling. During a super eruption, cracks rip open across that ground and magma forces its way up through them, like steam blasting out of a pressure cooker. Ash and gas roar high into the sky. It can start in multiple spots across a wide area, not one neat hole. The magma chamber underneath can empty so violently that the roof above it collapses, the land drops, and what's left is a massive bowl-shaped scar called a caldera. And Yellowstone is the prime example. About 631,000 years ago, Yellowstone had a massive eruption and it left behind a giant caldera about 30 by 45 miles across. Now it's a national park, but it's also basically a footprint, like a warning. If Yellowstone erupted again, the first super hot clouds of ash and gas could blast outward and burn everything nearby. Then the ash would spread. And ash is not like the fireplace dust. It hurts to breathe. It wrecks engines, and it can shut down flights and machines. Regular volcanoes mostly hit the area around them with lava. A super eruption turns the air itself into a real danger. Ash spreads far and jams the things we depend on. High up, sulfur can turn into a thin haze that will block some sunlight. That can cool things for a while and mess with growing seasons, even far from the eruption. And winds can spread that effect well beyond the US. However, geologists worry about something even worse. A kind of eruption that can keep going in waves and cover huge regions in lava. It's called a large igneous province. It's not one volcano, it's a whole stretch of crust that starts leaking lava through long cracks over and over for a long time. Instead of one giant explosion, it's more like Earth turning on a lava faucet that just keeps going. Imagine a crack in the ground hundreds of miles long. Out of that crack comes a sea of lava, but this isn't the sticky, slow stuff you see in Hawaii. This is hot, runny, fast-moving lava, and it doesn't stop. It spreads, floods low spots, stacks into layers, and then does it again. And that's what makes LIPs scarier than a supervolcano. They drag on. They can erupt in repeated pulses over hundreds of thousands to a few million years. We have scars to prove it right here in the US. About 17 million years ago, the Pacific Northwest ripped open and created the Columbia River basalt. Lava did not just coat the land, it drowned it. The total amount that erupted was around 42,000 cubic miles. That's enough to cover the whole US in lava about 58 feet deep. But how can Earth produce enough lava to bury a mountain range? It's because the planet is still churning inside. Imagine Earth like a pot of thick tomato soup sitting on a stove. Earth's core is the stove, and it's extremely hot. The soup is the mantle, a thick layer of rock that moves slowly. Now and then, a massive blob of superheated rock rises from deep in the mantle, possibly from the boundary above the core. Scientists call this a mantle plume. When it reaches the cooler crust, it spreads out, pushes upward, and when it breaks through, it does not build one neat mountain. It can open long cracks and feed eruptions in repeated bursts for a very long time. However, while lava burns everything in its way, it's not what wrecks the planet. The gas does. These eruptions release huge amounts of carbon dioxide and sulfur, and we can assume the consequences of that because it happened before, and not just once. About 252 million years ago, a massive LIP eruption began in what is now Siberia. It lines up with the worst extinction event in Earth's history, the Great Dying. Around 90% of species disappeared. Huge amounts of gas flooded the air and trapped heat. The ocean soaked up some of that gas and turned more acidic. Acid rain fell again and again. Life on Earth crashed. Scientists believe that in the last 500 million years, there have been 16 major extinctions like this, and that 15 of them line up closely with LIP timing. These geological formations changed Earth so many times, and scientists now wonder, what if Yellowstone and that massive lava flood in Oregon are actually a part of the same system? Look at Idaho from space, and you see a long, flat track across the state called the Snake River Plain. It points from the old lava flood region toward Yellowstone, like a trail. That path exists because Earth's surface moves. The outer layer is split into giant plates that slowly slide. Under Idaho and Yellowstone, a deep, hot zone keeps feeding eruptions. As the plate moves, the eruption zone shifts with it, leaving a long trail behind. That's why the rocks get older the farther you go from Yellowstone. It's the same heat source, just a moving target. And if you roll the plate's motion back far enough, that trail points closer to where the Columbia River basalts formed. That's why some geologists think the Northwest lava flood and Yellowstone could be connected parts of one long-lived system. Finally, if it's all part of one big apocalyptic system, is it time to pack the bags and flee to Mars? Will it happen again soon? Even if they share the same story, that does not mean the worst part is coming back soon. The lava flood chapter played out millions of years ago. Today, Yellowstone is simply where that deep heat shows up at the moment. And sure, it can erupt again, but the most likely eruption isn't some giant doomsday blast. It's a steam explosion, when super hot water flashes into steam and blows rock apart. Lava flows and smaller eruptions can happen too. The caldera-making nightmare is a rare one. If Yellowstone ever started building towards something big, it wouldn't be sneaky. You would see it coming. A lot more earthquakes than normal and the ground lifting faster than usual. The clearest right before signs would likely show up in the days or weeks before it. We cannot stop a planet-scale eruption. We can only watch for the warning signs and plan. But hopefully, if the planet decides to get rid of us, by the time it starts sending warnings, we'll already finish turning Mars into our new home. A giant crack, more than 2,000 miles long, is splitting open across Africa. Roads, houses, even schools are getting torn apart. Now, scientists think they've finally figured out what's causing it. An enormous column of scorching hot rock called superplume, rising from deep inside the Earth. And it's slowly pushing the land apart inch by inch. This isn't a small shift though. The continent is breaking in two, and the clue to what's going on could be hidden thousands of miles away in Hawaii. And why does the United States suddenly have a role in all this? Hang on, we'll get there. First, it's important to know this isn't new information. Africa has been slowly splitting for about 25 million years. This is happening in a region called the East African Rift System. It stretches thousands of miles from Ethiopia down to Mozambique and is the largest active continental rift system on the planet. And by that, I mean places where the Earth's crust is being stretched and pulled apart, causing faults, earthquakes, and volcanic eruptions. Scary stuff to say the least. Back in 2018, for example, a massive crack appeared near a small town just west of Kenya's capital, Nairobi. In some spots, it was about 65 feet wide. That's almost the length of 2 school buses parked one after the other. The whole thing was terrifying. It happened fast and left a trail of destruction. Roads were cut off, farms torn apart. People were on edge as the ground opened up beneath their feet. And I mean that quite literally. One man watched the crack rip straight through his home. He barely had time to grab a few of his belongings before his entire house collapsed. Sounds terrifying, right? Since it happened in the East African Rift region, panic spread fast. The media was all over it, claiming it was proof that Africa is splitting apart. People standing near the crack thought, oh boy, it's already happening. And many still believe that today. But that's not actually the case. At least not with that particular crack. Because after the initial panic, videos and photos of it revealed clues that it wasn't related to tectonic plate movement. First clue, the 2 sides of the crack didn't match. Like trying to fit the wrong puzzle pieces together. They simply didn't line up. Second clue, the gap wasn't one continuous line. There was some kind of soiled bridges in between. All this showed it was sudden erosion. I mean, some specialists believe the crack had once been filled with volcanic ash from nearby Mount Longonot. But then the region was hit with heavy rains. When water soaked through the soil, it washed the ash away, leaving the gap exposed. Problem solved. Even after the truth came out, it was too late. This event brought the whole Africa is splitting talk back. And here's the thing. Even though that crack had nothing to do with it, make no mistake, Africa is breaking apart. That's because the continent sits between 2 tectonic plates, the Somali plate in the east and the Nubian plate in the west. The problem is they're moving away from each other, and as they drift apart, the gap in the East African Rift keeps getting wider. Eventually, the Somali plate could split completely from the Nubian plate, creating an entirely new landmass, something on the scale of Madagascar or even New Zealand. You don't have to worry though. This process is super slow. So slow that none of us will see it finished. Experts say the continent is moving apart by about 0.3 inches a year in some places. To give you an idea, that's less than the length of your fingernail. So we can say this split will take millions of years, which is good news for the people living there. But that doesn't mean they won't feel the effects of this slow break. In fact, they're already happening. Take Ethiopia's Afar region, for example. Back in 2005, this area showed just how unpredictable the rift can be. In a short period, 420 earthquakes hit the area, opening up a massive fissure. What usually takes centuries happened in just a few days, completely challenging what scientists thought they knew about the speed of geological changes. Back then, the crack stretched for more than 35 miles, and life around it is still far from easy. Recent earthquakes destroyed much of the local infrastructure. 37 schools were damaged, leaving 5,000 students without classrooms. And that was just one part of the damage. As the tectonic plates keep moving apart, water will eventually flood into this region, creating a brand new ocean, according to some predictions. Countries like Zambia and Uganda, which are landlocked today, could one day have a coastline. That could be great news for them, as it might open up new trade routes and completely reshape their economies. Don't get too excited though. We won't be diving into the waters of this 6th ocean anytime soon. The splitting process will take another 5 to 10 million years. But it's tough to say exactly when, since big seismic events, like earthquakes, could make it all happen faster. So here's what we know. The Somali Plate and the Nubian Plate are in the middle of a dramatic tectonic breakup, slowly moving apart. Africa is breaking in two. Earth will probably gain a new ocean because of it. But until recently, we didn't know exactly what was triggering all of this. Like, yeah, those tectonic plates are moving, but why? I mean, is this massive geological process being driven by something happening in Earth's mantle? Or could it have a much larger, deeper source? Well, scientists think they may have finally cracked the mystery. They believe the continent is breaking apart because there's a deep mantle superplume, a huge column of hot rock beneath the East African Rift System. Think of it as a massive subterranean hammer pushing upward, pressing against the crust, and slowly cracking it apart. But here's the interesting thing. Scientists reached that conclusion thanks to something that happened in a completely different part of the world, Hawaii. Under this US state, there's also a plume of super hot rock rising from deep inside the planet. It melts the crust above it, and that's what fuels Hawaii's volcanoes. As the Pacific Plate drifts over this plume, molten rock breaks through in new spots, creating volcano after volcano. Over millions of years, that's how the Hawaiian Islands were formed. This Hawaiian plume contains noble gases like helium and neon. And you know where else scientists found those same gases? That's right, beneath the East African Rift System. Bingo! That discovery backed up the theory that a superplume is driving what's happening in Africa. And we call it super because it might be massive. You see, these same gases have been found in volcanic rocks from Kenya all the way down to Malawi. So everything points to the existence of a single superplume that stretches from the Indian Ocean to the Red Sea, not a bunch of several isolated sources. If their data and research are correct, scientists estimate that this superplume beneath Africa likely starts at the core mantle boundary, which is located about 1,800 miles deep inside the Earth. While the East African Rift System's chemical signatures are similar to those found in volcanic rocks in Hawaii, they're not identical. The Hawaiian plume is thought to be a narrow, rising stream of hot mantle, a bit like the movement inside a lava lamp. Africa's plume might be shaped differently, more like a large mass of hot, buoyant material rising from deep within the Earth. As it reaches the surface, this hot material hits the colder, solid outer layer and spreads out, pushing hard enough to crack it open and trigger intense volcanic activity across the region. And if this theory is right, we're watching a slow but unstoppable force that will redraw Africa's map and change the continent forever.
At the end of December 2021, an underwater volcano with a rather exotic name, Hunga Tonga, woke up after several years of sleeping. It did that with so much energy and strength that people heard the eruption from over 100 miles away. Then it went back to sleep. But a couple of weeks later, it woke up again with a force 7 times greater than the first time. It broke the island above it in 2 parts. The lightning storm that started because of the eruption was the most intense in recorded history. The sound waves from the eruption traveled around the planet several times. Someone even heard a loud boom from it in Alaska. And it started the first known mega tsunami since ancient times. This tsunami took the lives of 2 people as far as Peru and caused trouble for 2 fishermen in California. But that's not all. This eruption could change the weather patterns on Earth for years. You may see the first proof in the summer of 2024, which is forecast to become much wetter than usual. Scientists believe the eruption was caused by gas building up to a critical point. Different minerals, including anhydrite quartz and sulfides, were building up for several months until they blocked the flow paths and sealed the gas within Hunga Tonga. Normally, when a volcano erupts, the fumes cause a temporary cooling effect on Earth's surface. But Hunga Tonga's eruption was different. It didn't produce much fumes, but released a massive amount of water vapor, roughly equal to 60,000 Olympic swimming pools. The intense heat of the eruption turned huge amounts of seawater into steam, which then blasted high into the atmosphere. All that water vapor ended up in the stratosphere, a layer of the atmosphere that's too dry to form clouds or rain. Scientists don't have any observations of volcanic eruptions like Hunga Tonga to predict its effects on our weather patterns. They can't tell exactly how long these effects might last either. This is because the only way to measure stratospheric water vapor is with satellites, which have only been around since 1979, and there hasn't been an eruption similar to Hunga Tonga in that time. Experts from different countries started analyzing satellite data right after the Hunga Tonga eruption. They wanted to find out how long water vapor would stay in the stratosphere, where it would go, and, most importantly, what this would mean for the planet. The first big result of the eruption, at least partially, was a huge hole in the stratosphere that was hanging on for several months in 2023. By the time it appeared, the water vapor had reached the polar stratosphere over Antarctica. In the following years, there wouldn't be enough water vapor left to enlarge this hole. It looks like Hunga Tonga will have just a minimal effect on global average temperatures. But there are some surprising, lasting regional impacts. One of the scientific models forecasts colder and wetter winters for northern Australia until about 2029. In North America, it predicts warmer winters, and Scandinavia could have even colder winters. This is just one study though, and one approach to understanding how the eruption of Hunga Tonga can change our weather. We do have at least one example from history when a volcano eruption changed the world. Over 2 centuries ago, in 1815, Mount Tambora erupted and caused the year without a summer. In the following year, the winter was unusually cold and wet weather across Europe and North America. A recent study confirms that 1816 wouldn't have been this cold without the volcanic eruption. The immediate effects of the eruption were catastrophic, with tsunamis destroying homes, claiming 10,000 lives, and 80,000 more who fell ill in the aftermath. The eruption of Mount Tambora was one of the strongest in the last 1,000 years. It had ejected an enormous amount of sulfur dioxide into the stratosphere, which quickly spread across the world. It resulted in the coldest year in at least the last 250 years. In May, frost wiped out most of the crops in New York, Massachusetts, New Hampshire, and Vermont. By June, heavy snow covered the ground in Albany, New York, and Dennisville, Maine, and New Jersey had 5 straight nights of frost. The cold continued into late summer, which should have been the harvest season. In July, lakes and rivers were still frozen as far south as northwestern Pennsylvania, and frost stayed in Virginia until late August. Temperatures would drop from above normal summer highs to near freezing within just a few hours. The weather was completely unpredictable. Prices of food skyrocketed. The cost of oats for horses, which were the main mode of transportation, also rose sharply. Some people believe this situation inspired Carl Drees to invent the bicycle in 1817 as an alternative transportation method. Tambora changed weather patterns completely for not just 1, but 3 years. The whole planet got colder, and as crops failed, probably at least 1 million people starved. Scientists don't have solid evidence of volcano eruptions that have taken more lives than Tambora. But the Krakatoa eruption in Indonesia in 1883 is far more famous than Tambora because information about it spread worldwide via telegrams and photos. Its final blast was the loudest recorded sound in history, and people could hear it on 10% of the entire Earth's surface. The eruption started a tsunami with waves about half as tall as the Statue of Liberty. Still, it was less powerful than Tambora's eruption. The island that once hosted Krakatoa disappeared in the eruption, but new eruptions began less than 50 years later and created the Child of Krakatau cone in the center of the caldera of the old eruption. The new volcano still comes to life from time to time. Mount Vesuvius's eruption, which took down Pompeii, is one of the most well-known volcanic disasters in history. It took around 2,000 lives, much fewer than Tambora. According to a famous Roman author of that time, the eruption lasted 18 hours. Pompeii was covered by a layer of ash and pumice that was thicker than twice an average human height. The nearby coastline also changed dramatically. In today's world, the after effects of volcanic eruptions are often more dangerous than the eruption themselves. Thanks to advances in technology, we can now predict volcanic eruptions more accurately and use safety measures like evacuations and flight cancellations. But there's still a lot of risk that changes in weather patterns and drought all over the world, especially in areas like India, East Asia, and East Africa that are affected by monsoons. Volcano eruptions can also have effects you wouldn't probably expect, like the evolution of dinosaurs. These guys were once the size of cats, waiting for their time to shine. It came around 230 million years ago. This time is known as the Carnian pluvial episode. Before it, Pangaea was a dry and arid supercontinent. But then, there were 4 major volcanic events that pumped huge amounts of carbon dioxide into the atmosphere. Global temperatures and humidity spiked because of it. These massive eruptions most likely happened because of the Wrangellia Large Igneous Province eruption in what is now British Columbia and Alaska. This prolonged volcanic activity created the right conditions for dinosaurs to blossom and diversify, and also for the rise of other groups, like modern conifers, ferns, crocodiles, turtles, insects, and early mammals. With higher temperatures and more rainfall, terrestrial plants have evolved, and humidity-loving ones have become dominant. Without those changes in the world, we could have a completely different natural history. There's some solid proof that volcanic activity has really changed the weather patterns back then. Scientists have found layers in the Earth's core that show different types of carbon. It means there were 4 massive releases of carbon dioxide into the atmosphere. The data on mercury and carbon together shows that the spike in mercury levels was thanks to a major volcanic event that affected the global carbon cycle and not just local eruptions. India could split horizontally into 2 parts as it runs into Eurasia. The movement of the Indian plate that includes most of modern South Asia is causing the Himalayas to grow. This process started around 60 million years ago when the plate first bumped into Eurasia. Scientists from the Netherlands have used the power of an AI simulator to see what this region will look like one day. The computer model showed that the Indian subcontinent will merge with the Horn of Africa in approximately 200 million years. The present-day cities of Mumbai and Mogadishu will become next-door neighbors. They will sit along the newly formed mountain chain scientists provisionally named the Somalaya. On the other side of this geological formation, Madagascar will connect with Sumatra, while Calcutta and the island of Mauritius will occupy the same region. Sri Lanka would cease to exist as it becomes part of the Indian mainland. Further to the north, scientists predict that the Himalayas are going to increase in height in the foreseeable future. As the Indian plate continues to mile northward, there will be major changes to the surrounding landscape. The present fault line will drift further south. Tens of thousands of years in the future, there might be no Nepal. The Himalayan range will have expanded sideways to fully engulf the mountainous country. And there may be way more earthquakes in this part of the world because of this movement. Most researchers agree the speed at which India is moving northward into Eurasia is barely 1/10 of an inch every year. Some of them think this is happening because of the plate's buoyancy. It prevents the Indian plate from sinking into the mantle, which gives Tibet its elevated topography. Other scholars believe that the structure is buckling under the pressure. The process resembles what happens to a sheet of paper when you push it horizontally against a wall. As you apply more pressure to its edge, the sheet starts to rise in the middle. In the real world, this bulge would be the Tibetan Plateau. A recent theory gives us the third explanation for the process. Their paper still has to undergo peer review, but the findings are intriguing. The international team of researchers introduced a new concept: the delamination of the Indian plate. This term simply means the separation of layers in a material that is supposed to be bonded together. Think of a sandwich that has cheese and ham slices between 2 buns. Take one of those layers out of the sandwich and you get delamination. In geological terms, this process involves the upper part of the plate peeling off and moving upwards. In the case of the Indian plate, this is the section that supports Tibet's elevation. The lower section is denser, which causes it to sink into the mantle. Plate tectonics are, in this way, similar to a layered cake. Chefs place the spongy, denser layer at the bottom, so the heavier top doesn't crush it. Scientists developed their thesis by analyzing helium gases in water samples from the region's hot springs. Helium-3 is a rare isotope that shows that the mantle is close to the surface of the Earth. Researchers measured helium isotope ratios at 200 Tibetan springs. The pattern they saw shows how close the mantle is to the northern Tibetan surface. Further to the south, they found plenty of helium-4, another isotope, which means that the plate is intact. It forms a barrier that helium-3 cannot penetrate, except in one region near Bhutan, in the eastern part of the Himalayas. The seismic activity in the region is good proof that delamination, the sandwich theory, is all real here. And it shows us that the mantle is intruding from the eastern side of the plateau. This concept puts under question the old, established ideas about tectonic plate behavior. The scientists behind the study suspect that the unique shape of the Indian plate contributes to the delamination process. It's the thickest at the northernmost point and the thinnest on the sides. If it's all true, it will mean that the continental collisions have a more dynamic and complex nature than geologists previously believed. Scientists still don't have enough hard evidence to prove the correctness of the new theory, just hints. Drilling to depths of over 60 miles is mechanically impossible right now. Such excavations are necessary to be 100% sure that the delamination process is going on. With the right technology, we would be able to better understand the hazards associated with earthquakes in the Asia-Pacific region. It's home to the famous Ring of Fire, where 75% of Earth's volcanoes are located. 9 out of 10 all earthquakes take place here. The India-Australia-Capricorn tectonic plate beneath the Indian Ocean is also important for solving Earth's tectonic mysteries. The term geophysicists use for such locations is nascent plate boundary. These are plates where tectonic plates are just starting to pull apart or push against each other. They represent the initial stage of a full-fledged plate boundary. Such a geological transformation unfolds at a pace of barely 5% of a single inch per year. That's about as long as a strand of spaghetti is wide. This shouldn't worry us too much from today's perspective. The India-Australia-Capricorn plate is destined to split in half over the course of tens of millions of years. Scientists from France studied records of 2 earthquakes that happened in 2012 and concluded there must be a nascent boundary there. Earthquakes normally occur at places where 2 or more tectonic plates meet. But the tremors in the Indian Ocean happened in the middle of the plate. The scientists used sonar scanning to map out the sea floor and see what was really going on there. After further examination of the marine area off the coast of Western Australia, researchers found a complex network of 62 pull-apart basins along a fracture zone. The scientific data backed up the idea that the tectonic plate was slowly but surely breaking apart. It's another proof that the outer layer of our planet is dynamic, not static. In some cases, you don't have to be a scientist to notice these powerful underground forces. Massive crevices emerged almost overnight due to heavy rainfall in a seismically active region in rural Kenya, first in 2018 and then again in 2023. The local population named the biggest of them the Grand Canyon. These events were not one-time incidents, but signals from the East African Rift System, part of the Great Rift Valley. This huge geological phenomenon stretching from Jordan to Mozambique shows us the gradual splitting of the African continent into 2 subcontinents. You can find rift valleys all around the world as proof of how tectonic plate movements are changing the planet. The East African Rift shows the underlying dynamics of the Nubian and Somali plates. The Nubian plate bears most of Africa, and the smaller Somali plate cradles the Horn of Africa. The 2 are gradually moving away from one another, which causes the formation of crevices within the Rift Valley. This process of continental rifting, going on at a rate slightly faster than the one in India, will eventually lead to the split of Africa into two continents. The whole process, which is about to happen in the next 10 to 50 million years, marks a significant geological event that reminds us of Earth's historical transformations. The last time our planet's geography changed so drastically was during the Jurassic period. The world map from the period looks recognizable, but the land masses were oddly positioned from the modern perspective. In the north, Eurasia was still loosely connected to North America, which was at the time called Laurasia. This landmass was slowly moving away from the supercontinent of Gondwana, further down south. It consisted of what we know today as Africa, South America, Australia, and Antarctica. At the time, the Indian plate was closer to Madagascar than to Eurasia, as it is today.
In 2015, a volcano erupted, and the seafloor dropped about 8 feet, like an elevator giving up mid-ride. By then, scientists had already put wires and sensors all over the place. The idea here was simple. Since it erupted fairly often, they wanted to predict the next disaster. And they sorta did. They circled 2025 in red and waited. Except nothing happened. But the ground is still swelling and quaking almost daily. And now everyone is worried. Let's see why. Axial Seamount is a volcano about 300 miles off the Oregon coast. But to really find it, you would need to dive almost a full mile. You'll also find something unexpected there – yellow cables, miles of them. This is one of the most watched volcanoes on the planet. Through a massive project called the Ocean Observatories Initiative, or OOI, scientists draped the underwater mountain in 550 miles of fiber optic cable. Sadly, it's an observatory in name only, serving more as a science experiment than a proper observatory. There's no cool-looking dome where people live and research underwater. These cables power a massive network of sensors. They count earthquakes, track the ground rising by fractions of an inch, and listen to the magma rumble. These sensors are so sensitive that they can feel the moon. When the tides rise, the extra water presses down on the volcano and sets off tiny earthquakes. To put this all in place, they had to use remote-controlled robots that dove down and physically plugged those sensors into the network. Plugging a TV into an extension cable in a dark room is hard. Now imagine doing that 4,600 feet under the surface. You're using a robot arm, and the pressure is strong enough to crush a small pickup truck. But why go through all this trouble? Volcanoes are lazy, most sleep for centuries. Some wake up once, flood half a continent with ash, and then go quiet for hundreds of millions of years. If you study volcanoes, you might wait your entire career and never see a single drop of lava. But Axial sits right where two tectonic plates are ripping apart. Magma is constantly refueling the tank. It's not the type that needs to wait hundreds of years to recharge. It can erupt every decade or so. Now, it doesn't blow its top like Mount St. Helens. There's no earth-shattering kaboom. Instead, the ground swells up, cracks open, and lava pours out quietly to create new rock. When the floor cracks, it blasts out a massive cloud of superheated water called megaplume that's packed with subsurface bacteria. It rises thousands of feet high and looks like a blizzard of white snow shooting through the dark ocean. Each eruption basically resets the biome, forcing life in the area to start over. That combination, frequent and calm, makes it perfect for study. It erupts often enough that we can actually collect data, and is predictable enough that we can build a model around it. By 2014, the observatory had already been in place, just in time for the eruption that happened in 2015. Scientists caught the whole event live. They had sensors on the seafloor that showed the ground puffing up like a giant balloon as melted rock gathered underneath. The ground rose up several feet until the pressure made the rock start to crack. This caused thousands of tiny earthquakes in just one afternoon. Then, miles-long cracks ripped open and lava poured out. As that magma leaked out, the ground lost its support. Eventually, the seafloor inside the volcano's crater collapsed. The whole point of capturing 2015 was to build a baseline. This is what right before an eruption looks like. So when the crater floor started rising again and the quake counts climbed, scientists figured Axial was heading toward another eruption in 2025. And then, nothing. Nada. Zippo. The signals reached the same zone that worked last time, but there was no eruption. It's like pumping air into a tire until it should blow, and it doesn't. So what went wrong for the researchers expecting a quiet explosion? What likely happened is that the volcano stalled. In 2015, the ground rose quickly, but nature likely changed the tempo. Magma is still filling the chamber, but it's pumping in slower than it did 10 years ago. It's also possible that the rock is stronger now, holding cracks better, forcing the volcano to swell even more. Now, there's also a third option, a quiet leak. Tiny fractures could be hissing out just enough pressure to delay the main event, keeping the volcano in a state of suspended animation, ready to blow but lacking the spark. And even with all the data, it's still hard to tell the difference between almost ready and about to break. That's why the forecast slid from 2025 to mid to late 2026. The volcano stayed active, but the buildup slowed, pushing the breaking point back by about a year. But why is this making scientists nervous? When you hear about the consequences of eruptions, it's easy to imagine a tsunami heading for the coast. Well, it's not. You can keep your surfboard in the garage. This is a deep ocean event. The water absorbs almost all the energy. The surface might get a little bubbly, but nobody on the beach is going to spill their drink. The people sweating are the ones who paid for the robots. The problem is that the lab is sitting inside a test tube. Remember, the volcano is currently overcharged. It has already swelled past the point where it usually pops. If it waits until late 2026 to finally let go, it could have accumulated significantly more magma than it did in 2015. A bigger eruption means new, cool data, but it also means a much larger volume of lava. Those expensive yellow cables and delicate sensors, they're sitting right in the splash zone. If the lava follows the old paths, the gear is fine. But an overpressurized release could rip open new cracks in the seafloor. If that happens, researchers could lose millions of dollars of equipment in seconds. Scientists might be watching the feed live, see a wall of molten glass, and then static. But the real worry isn't the money. Axial is supposed to be the gold standard. It's the most monitored square mile of the ocean floor on Earth. It was supposed to be the easy one. If our prediction model fails here, well, it's a bad sign. We have every sensor imaginable, and we still don't understand underwater volcanoes as well as we thought. If we can't predict the friendly volcano when it's wired for sound, what chance do we have with the dangerous ones? The vents around the volcano pump out water that could reach around 650 degrees Fahrenheit. On the surface, that would instantly turn to steam. Down here, the pressure is so intense that the water can't boil. But it's so hot it can dissolve minerals. The place is also loud. If you could hear it, it would sound like a jet engine on a runway. Plus, the area is carpeted in tube worms. They look like giant 6-foot-tall white pipes with bright red tips. They don't make biological sense. They have no eyes, no mouths, and no stomachs. They don't eat food at all. Instead, they host bacteria inside their bodies that turn the volcano's toxic sulfur gas into sugar. They're basically powered by pollution. Crawling all over them are scale worms. These things look like they belong on some other planet. They're covered in microscopic scales that refract light. So if you shine a flashlight on them, you could see them sparkle in blue and red. The ground beneath them is also strange. When Axial erupts, the lava hits the freezing seawater and cools instantly. But it doesn't turn to gray stone. It turns into glass. Pure black obsidian. If you tried to walk on it, it would sound like you were walking on thousands of light bulbs. Experts have updated the schedule for this year. Cameras are in place to take some cool pictures, and we might even get a live stream on YouTube, watching the ground tearing open under the ocean. Let's just hope that it isn't the final broadcast. It's really hard to stream the next one if your multi-million-dollar camera ends up digested by a river of molten glass. I'll say.
It was June 1928 when Mr. Keller almost lost his life in a terrifying natural disaster. He was outside with his family when he noticed an umbrella-shaped cloud that seemed to be approaching them. It gave him a sense of foreboding. A tornado was probably forming there. Indeed, in no time, 3 huge funnel clouds were dashing their way. After rushing his family into the storm cellar, Keller decided to have another look, and what he saw both terrified and mesmerized him. The twister was directly overhead, but inside the swirling cloud, everything was eerily still. The man could feel a strong, grassy smell. He had trouble breathing. He looked up and saw a circular opening right overhead. It was around 50 to 100 feet across and around half a mile high. Keller could clearly see the walls of the rotating cloud. Constant bursts of lightning zigzagged from side to side non-stop, illuminating this horror movie scene. The man could also see many smaller tornadoes forming and breaking free. A deafening, hissing noise was overwhelming. And the next moment, the tornado skipped over Keller's house and smashed the home of his neighbors. Mr. Keller wasn't the only person to see the tornado from the inside and live to tell the tale. But other survivors didn't end up as unscathed. It seemed to be a regular day when Chris Tubing from Dallas, Texas got to the Little Caesars in 2019. They had run out of pizzas, so he decided to wait. Well, it was a grave mistake. A powerful tornado hit the shopping mall where he was staying and pulled him out of the building. Chris managed to find a support column and held on for dear life. But no muscle strength could compare to the terrifying power of the tornado. Tuvang was lifted into the air and thrown into a truck parked in front of the restaurant. He tried to hold on to the hood, but there was nothing to grab. In the end, he managed to hold on to the rim of the left front tire and stayed there until the whole nightmare stopped. The tornado Chris survived had sustained winds of 140 miles per hour and was 13 football fields wide at the base. Eric Simmons recalled taking cover from a tornado in May 2019 by climbing into his truck. Once inside, he looked out of his right windshield and saw vines growing along the fence. They were moving around in a bizarre way that confused the man. And then it all started. Suddenly, everything Eric could see was wind and pitch-black darkness. Then, a section of a roof flew over him and shredded apart mid-air. The truck's back windshield shattered, showering the man with shards of glass. A tree in front of him was lifted into the air like a twig, and the fence blew over the top of the truck. Simmons could feel the back of the vehicle lifting. He could see the power lines exploding right in front of his eyes. Even though the visibility was terrible, he could still see the flashes. It all lasted around 45 seconds, but to him, an eternity seemed to have passed. When the coast grew clear, Eric got out of the car, but he could barely walk after the shock he had lived through. He couldn't speak. It was one of the most horrifying and traumatic experiences of his life. According to the man, the real reason why he was so terrified was because he had no training, no warning, and no defense against whatever was coming. Later, he found out that the tornado had almost taken his life at a speed of 86 to 110 miles per hour and was around 75 to 100 yards across. A tornado is a rotating column of air that touches the ground. Sometimes it's connected to the base of a thunderstorm. The wind speeds inside tornadoes can top hundreds of miles an hour. No wonder they have enormously devastating potential, picking up objects, unrooting trees, destroying buildings, you name it. The problem with escaping a tornado is that it's not always easy to see. The wind, however severe it is invisible. The first sign of an approaching tornado might be the infamous rumble resembling the noise a moving freight train produces. There are also some other sounds indicating that a tornado is coming, but the human ear can't perceive those. When you spot that classic tornado cone, it means it has already developed a condensation funnel made of water, dust, and debris. The most destructive tornadoes are born from rotating thunderstorms, called supercells. Luckily, those are something meteorologists can actually notice because such storms have a well-defined appearance on radars. Experts believe that the difference in the temperature of such a storm can determine how likely a tornado is to form. And still, there's a lot we don't know about this process. For example, the question about why and where tornadoes are most likely to appear remains unanswered. The strength of tornadoes is measured with the enhanced Fujita scale. The rating goes from 0 to 5, considering the damage caused by a tornado and its wind speeds, where EF0 is the weakest tornado and EF5 is a tornado I hope you will never ever come across. The EF scale rounds off at wind speeds of 318 miles per hour, with strong frame houses being lifted off foundations and carried long distances to be eventually broken into pieces. Cars fly through the air for more than 328 feet away, and steel-reinforced structures are left badly damaged. Despite this terrifying power and ferocity of tornadoes, authorities report that even the worst of them have a 99% survival rate. But it doesn't mean that you shouldn't take all possible precautions to avoid ending up inside one. Stay away from doors and windows. Move to an interior room if possible, and use pillows, blankets, and mattresses to protect yourself from flying debris. If stranded outside during a tornado, crawl into a ditch and cover yourself, protecting the head. Now there's another twister that is as scary as a tornado, but this one forms in the water. Whirlpools appear when fast-flowing water crashes into an obstacle or another current. The water starts swirling in a downward spiral, creating a vortex that can pull objects, animals, and even small boats that happen to be nearby to the bottom. One more way for a whirlpool to form is the sudden appearance of a sinkhole created by a collapsed cave, for example. This makes water flood the hollow structure and creates a whirlpool similar to the one you see when you pull the plug out of a bath filled with water. While some whirlpools are small and brief, others can reach enormous sizes and be driven by constant currents. The most dangerous of them are maelstroms. If you get into a whirlpool like that, your chances to get back to the surface are slim. The incessant movement of the water and its pulling power can leave you disoriented and stuck without air. That's what happened to Stuart Falstone when he got trapped in a whirlpool. His first instinct was to swim out of it, but this idea proved to be hopeless. The footage filmed by the cameraman attached to his helmet later showed that the man had been underwater for almost 3.5 minutes. He had probably been dragged all the way down to the riverbed. There, the pull of the twister lessened a bit and finally released its hold. The guy was lucky to get spotted face down in the water and pulled to the surface by a kayaker. The depth a whirlpool can pull you down to can vary. It depends on its power and size. Sadly, not everyone who got trapped in a whirlpool survived and got out again. In different ways in which whirlpools form means that sometimes they can appear out of the blue. You can't predict this process and get no warning. So the best way to stay safe is to wear your life jacket at all times when in the water. If you get pulled into a whirlpool, try not to move in the same direction as the water flow. Aim for the outer edge rather than the center of the twister. If you're lucky, the whirlpool might throw you back up. There have been precedents. And if you come over a whirlpool in a boat or kayak, do your best to stop the boat from filling with water. The snowpack over your head splits in two right in front of your eyes and starts tumbling down in the frozen slope to its resting place far, far below. Anything in its way is crushed under the immense mass of snow and debris. You're witnessing an avalanche, one of the most dangerous natural disasters. But what if I tell you about another kind of avalanche, no less blood-chilling than the mountain one? And the most bizarre thing about it is that it occurs underwater. Underwater avalanches are powerful and disastrous natural phenomena, often much more dangerous than land ones. They have the potential to wreak havoc on the entire planet, leading to catastrophic consequences. The most alarming thing? They occur all the time under the surface of the ocean, impossible to see, predict, and extremely difficult to measure. Such avalanches can get 100 times larger than land ones, and they pose a great risk to the world's communications, capable of leaving the entire planet without the internet. But we'll talk about it a bit later. First, let's go 60,000 years back into the past. We're near the northwest coast of Africa, ready to witness the colossal scale and devastating impact of a ginormous underwater avalanche. It started as a quite small underwater landslide in the Agadir Canyon. At first, it was just 0.35 cubic miles of material, but in no time, this mass increased more than 100 times in size while traveling across the Atlantic Ocean floor. As the avalanche sped up and grew, it picked up gravel, sand, rocks, and mud. It carved a devastating path through one of the world's largest submarine canyons, wiping out all forms of animal and plant life on its way. The disastrous flow was so powerful that it literally eroded a 250-mile stretch of the canyon, cutting hundreds of feet into its sides and damaging a total area of 1,740 square miles. That's the area of more than 3.5 New York cities. As for the force of the flow, it was so immense that it propelled massive boulders up the canyon walls to heights of up to 430 feet. Before scientists discovered the evidence of this catastrophic event, they had seriously underestimated the scale of destruction caused by submarine avalanches. By the way, these devastating catastrophes can start not only far away in the ocean, but also at estuaries. Let's go back to 14 January 2020 and see for ourselves. A turbidity current, a rapid, downhill flow of water containing a lot of sediment, rushed more than 680 miles from the Congo River estuary in the deep sea. This current appeared due to two factors: terrible flooding along the Congo River in late December 2019 and unusually large spring tides. This resulted in an avalanche of sand and mud. Its volume was equivalent to 1/3 of all the sediment produced annually by all the rivers in the world. This sediment avalanche accelerated, increasing in speed from 17 feet per second in the upper part of the Congo Canyon to 26 feet per second when it reached the end of the channel, almost 700 miles away from the coastline. This route made it the longest avalanche of sediment ever measured on our planet. 2 days later, the flow reached the deep ocean. The avalanche broke 2 seabed telecommunication cables, cutting internet data speeds all the way across West, Central, and South Africa. Now, before this disaster, scientists considered that measuring powerful deep-sea avalanches was impractical. But the sediment flow in the Congo Canyon could be monitored directly, finally allowing researchers to assess how major river floods connected to the deep sea. They also concluded that how often underwater avalanches occurred depended on where the observer was. Seafloor canyons that are close to river mouths can experience several tiny avalanches per year. Other systems, far from river discharges like the Agadir Canyon, can only have one monster of an avalanche every 10,000 years or so. You're likely wondering, what can trigger an avalanche under the surface of the ocean? Well, earthquakes, typhoons, high tides, river floods, and even volcanic eruptions. And due to our changing climate, such events become more and more frequent and intense. At the same time, these triggers don't mean that an avalanche is bound to happen, nor do they relate to the scale of the event. See for yourself. In 1755, a powerful earthquake hit the coast of Portugal, wiping out large parts of Lisbon. Tens of thousands of people lost their lives during that disaster, but it only triggered a tiny underwater avalanche. And in 1929, a large earthquake off the coast of Newfoundland, Canada, triggered the largest underwater avalanche ever recorded. The flow traveled at a speed of 42 miles per hour, carrying boulders, sand, and mud. It snapped 11 seabed cables on its journey downhill. The avalanche was so powerful, it produced a tsunami that claimed the lives of 28 people along the coastline. Now, submarine avalanches are totally invisible because they happen deep under the ocean surface, which makes them extremely hard to study. But we must find a way because these flows are super important. They transport sediments, nutrients, and even pollutants across the ocean floor. So, a research team from Liverpool decided to unravel this mystery. Over the last 40 years, they've collected more than 300 samples from the ocean floor. Combined with seismic and bathymetric data, which is a fancy word for ocean mapping, they managed to reconstruct a massive submarine avalanche. It was the first time an underwater avalanche of this size was mapped out. An even cooler thing, the event itself started off pretty modestly, but it quickly evolved into a colossal avalanche that grew to more than 650 feet tall. To put that into perspective, imagine a skyscraper-sized avalanche zooming from Liverpool to London, cutting a trench 100 feet deep and 9 miles wide. Then it spread out over an area bigger than the UK, covering it with several feet of sand and mud. That's like burying a whole country. These findings are actually a big deal because they show that even a small underwater landslide can turn into something massive and super destructive. But that's not the worst. Think about undersea internet cables, which are essential for global communication. There are more than 550 active seafloor cables around the world. Their combined length is a whopping 870,000 miles. That's enough to wrap around our planet 35 times. When a submarine avalanche breaks seafloor cables, the effects are usually super expensive and devastating. For example, in 2006, an earthquake in Taiwan triggered underwater avalanches that cut loads of seafloor cables connecting Southeast Asia with the rest of the world. The largest internet operator in China had a 90% loss of traffic to the USA at the peak of the event. As for Taiwan itself, it experienced between 74 to 100% loss in traffic to neighboring islands. So now you probably get why we need to learn more about this natural phenomenon. Luckily, researchers at Tulane University have found a way to study it in 3D. Previous studies only looked at submarine avalanches in 2D, which didn't give the full picture of how they actually behaved. The new research focused on how underwater flows interacted with mini basins, natural features on the ocean floor that look like shallow bowls. Despite being called mini, these bowls can be huge, up to 4 square miles. When turbidity currents flow into these mini basins, they don't just stop. No, they hit the far side and curl back around like water eddies in a stream. These swirling flows move the sediment around before it settles on the ocean floor. The size of the mini basin and the speed of the flow can change how the current behaves. If the basin is big and the current is slow, it starts to fill up with sediment. But if you crank up the flow speed or shrink the basin, the current starts to overflow, spilling over the basin. To study all this, the researchers created a mini version of a mini basin in a pool and used different speeds of flow to simulate turbidity currents. They even made their own sediment mixtures to see how different sizes of particles would behave. In the end, they managed to mimic real-life ocean conditions, but on a smaller, manageable scale. Pretty cool, huh?
The ear-piercing sound of sirens brings your relaxing Saturday afternoon to a screeching halt. You jump out of the chair and run to the window. The sky is covered in black clouds all the way down to the horizon. The trees are nearly bent over flat from the gale-force winds. Together with the rain, golf ball-sized hail crashes into the ground, on rooftops, on parked cars. It sounds like a stampede right over your head. Car alarms are going off everywhere. Just then, crack! Huge bolts of lightning flash across the black sky. Then the monstrous grumble of thunder. Your heart jumps in your throat. As you peer through the window at the sudden chaos outside, you're filled with a primal fear of the power of nature. You snap back to reality. The sirens! Gotta get to the basement! You start to turn away from the window, and that's when you see it. A massive tornado ripping along the city street. It's throwing entire motorcycles, refrigerators, and even trees like baseballs. The roof of that building starts peeling off like a Band-Aid. The twister even lifts cars and pieces of asphalt as if they're made of feathers. It seems this tornado will flatten your city within an hour tops. You finally snap out of your hypnosis and run to the basement. The sound of the city being ripped apart terrifies you as you hunker down below as low as you can. But after about 20 minutes, everything is suddenly silent. You head out to see the clouds have disappeared, and the sun's rays illuminate the street. Luckily, your house was spared, but your modern city now looks more like ancient ruins. Stop. Tornadoes never come into cities, right? Yeah, they do. This monster doesn't care where it goes and what it eats along the way. While we're at it, you can forget about the myth that tornadoes will magically stop when they meet rivers, lakes, or mountains. They just keep on going. But about that no twisters in the city thing, about 1,000 tornadoes hit the US each year. That's 75% of all the tornadoes in the world. Most of these monsters occur in a strip, okay, more like a long blob, running up and down through the middle of the country. It's an area aptly dubbed Tornado Alley, a perfect spot for these things to form. You get cold, dry air coming down from Canada, meeting warm, humid air traveling north from the Gulf of Mexico. Warm air is less dense than cold air, so it rises and creates a strong updraft. Water droplets surround it to create the funnel cloud. There you go, recipe for a tornado. Now, if you closed your eyes, spun around, and put your finger on a map of the US, the chances of your finger landing on a major city are pretty slim. If you gathered all the cities in the whole country into one area, it would only be 3% of the US's entire land. Just like your finger, the likelihood of a tornado striking in the city is much smaller than landing in a rural area. When it comes down to it, tornadoes can touch down in big cities. They just hardly ever do, thanks to sheer chance. Another surprising myth: you always see a tornado coming because, funnel cloud right ahead. Not true. The approaching funnel can be completely camouflaged in a wall of rain. You might finally see it when it's right on top of you. In this case, you'd better trust your hearing. First, tornado warning sirens go off if you're in a place that has them. Second, listen for a loud rumble that sounds like a train coming. That's a sure sign this beast is somewhere nearby. Many people immediately start heading for shelter when they see green clouds in the sky, because we all believe it's the #1 sign of a tornado coming. Don't buy it. Yes, a green sky is a sign of a severe thunderstorm that's powerful enough to produce tornadoes, but it's not a guarantee like many people see it. While we're at it, you know how movies show the ground ripping apart during earthquakes? The gaping hole that swallows cars, houses, entire cities? Not a shred of truth to this. A crack may appear in the ground with major earthquakes, but it rarely exceeds a couple feet wide. One of the most overspread myths out there is that lightning will never strike the same place twice. Tell that to the Empire State Building. It gets hit by bolts of lightning at least 25 times a year. Pretty sure nobody's picking the building up and moving it to different locations. Yes, lightning likes really tall things, and it's not shy to keep coming back. As for that old warning about your cell phone or jewelry attracting lightning, busted. There hasn't been any scientific support for the idea that personal objects with metal in them attract lightning. You still shouldn't be out and about during a storm though, cell phone in hand or not. Now, if you're looking for a tsunami and only focused on giant walls of water, you might never see one, even if it's right in front of you. Tsunamis aren't always massive tidal waves crashing into the shore. More often than not, they look like the tide is rising extremely rapidly, receding and rising again until it overspills into the city. Not that tsunamis never form walls of water, it's just not as common. Picture Earth. Are you imagining a perfect ball? Well, to resemble the truth more, squash the poles down a little. There, now you have a realistic Earth. Scientists call the Earth an irregular sphere, or ellipsoid in fancy terms. The planet rotates on its axis, causing the equator to bulge out a bit, just like what happens when you spin fast on a merry-go-round. You feel pulled out and away from the center. What's the highest point on Earth? Everest, of course. But if we go from the point furthest away from the center of the Earth, The crown goes to Mount Chimborazo in the Andes. Its peak is actually 6,800 feet closer to space than the summit of Everest. That's because Chimborazo sits near the equator, where the planet's bulge is greatest. The blue whale weighs as much as 30 elephants, makes sounds louder than a jet, and eats 4 tons of food every day. It's the largest living creature this planet has ever seen. Only, not technically. Head to the Malheur National Forest in Oregon, home to a creature that weighs as much as 20 blue whales. The honey mushroom is a humongous fungus colony united into a common system. The giant covers an area of 1,500 football fields, and it's thousands of years old. Ask anyone to draw the sun, and they'll draw a happy yellow circle. But if you look at our star from the moon or the International Space Station, you'll see that it's actually white. From Earth, the sun looks yellow or red thanks to the atmosphere acting like a filter. Most people think time is constant and moves at the same speed no matter where you are. But the speed of time depends on how close the watch is to Earth. The weaker the gravity, the faster time passes. So the person living in the apartment above you is aging faster than you. Now, it's only 90 billionths of a second faster per 1 foot higher, so don't expect to notice a difference if you decide to move to the first floor. The ground under your feet feels pretty solid and whole, but in reality, the Earth's crust is all broken up into plates surfing on oceans of liquid rock called magma. You don't feel it, but the ground under you is moving a little over ½ an inch per year. That's about the same rate your toenails grow. Largest desert in the world? Easy. The Sahara. Nope. It's Antarctica, which is almost 2 times bigger than the Sahara. A desert isn't just a scorching sandy place where it doesn't rain. It's a place with very little precipitation, so that includes snow too. In some parts of Antarctica, it hasn't rained or snowed for millions of years. In other parts, snow does fall, though rarely. Point is, there's a myth that it doesn't snow in extreme cold. Antarctica is the coldest place on Earth, and it snows there. There is some truth to this old saying. Cold is drier. It doesn't retain moisture as well. You need moisture to produce raindrops and snowflakes. That's why there are fewer chances for snowfall when temperatures drop so low.
You're walking through a bustling town near the Bay of Naples. It looks full of life, energy, and healthy food. Look at these flatbreads that might have been ancient pizza, no less. The people of Pompeii are living their best lives. But all of that comes to a fiery halt in 79 CE. That's when Mount Vesuvius, that unassuming mountain looming over the city, decides it's time to make history. And the result is a tragic story that archaeologists are still piecing together 2,000 years later. Now, if you think Pompeii was some boring, dusty old place, well, think again. This was a lively, buzzing town. There were farmers bringing in fresh produce, merchants selling their goods, bakers cranking out bread and pizza-like flatbreads, and gladiators gearing up for fights in the amphitheater. The people of Pompeii loved decorating their homes with frescoes, mosaics, and statues. And food was a big deal. Pompeii was home to some of the earliest restaurants, called Thermopylae, where people could grab hot meals on the go. But let's get back to the fateful day when this beautiful, simple life ended. The saddest thing is that the people of Pompeii had warnings. They just didn't know it. Around 4 days before Vesuvius erupted, there had been minor tremors, but the locals were used to earthquakes. They had a massive one in 62 CE that destroyed lots of buildings, but they rebuilt the town and kept living there. No one thought, hey, maybe that giant mountain is the problem. So by the time 79 CE rolled around, Pompeii was back to normal, or so they thought. Now it's the morning of the eruption, just another regular day. People are working, shopping, and chilling in the baths. And then, out of nowhere, Vesuvius erupts. It was a catastrophic explosion that shot a plume of ash, gas, and rocks 20 miles into the sky. Pliny the Younger, a Roman writer who watched this disaster unfold from across the bay, wrote that it looked like a pine tree of fire and smoke rising into the heavens. Suddenly, it began raining with ash. First it was a drizzle, then it started coming in buckets. Gray, heavy rain that didn't let you breathe. Then hail began falling from the sky. But it wasn't hail. Those were pumice stones, light chunks of volcanic rock. They were smashing roofs and windows and piling up in the streets. That's when people started panicking. Some of them decided to escape, so they ran from the town. Others thought the walls of their homes would protect them. Well, they didn't. Soon things turned even worse. The ash had covered Pompeii's streets, and buildings were collapsing under its weight. But the real nightmare came early the next morning. Pyroclastic flows, a fatal avalanche of superheated gas, ash, and rock that was racing down the side of a volcano at more than 200 miles per hour. The heat alone, around 1,000 degrees Fahrenheit, instantly finished the life of anyone who ended up in the way of the flow. When the pyroclastic flows hit Pompeii, it was, unfortunately, game over for the town. Those who decided to stay in the city didn't stand a chance. The people were trapped so quickly that their bodies were left frozen in their last moments, some shielding their faces, others holding loved ones. In one bakery, archaeologists found the skeletons of 3 people who'd stayed behind. They thought the oven's stone walls would protect them, but those just weren't strong enough to resist the elements. When the eruption finished, Pompeii was covered with 20 feet of volcanic debris. What archaeologists eventually found when they uncovered the town was both mesmerizing and terrifying at the same time. Because Pompeii was buried so suddenly, everything remained preserved: homes, streets, art, food, and even people. These days, scientists are rethinking what we know about the victims of the Pompeii disaster, thanks to new DNA evidence. Apparently, a lot of our assumptions about who these people were might be way off. A recent study by researchers from the US and Italy has shaken things up. They found that some of the victims, who they assumed were family members, weren't related at all. On top of that, the gender of some individuals was misidentified. The researchers believe that older interpretations were influenced by modern ideas about gender and relationships, which might have clouded the actual history. One of the study's co-authors from the University of Florence pointed out that conclusions based on limited evidence often reflect the biases of the time. Back then, researchers had to rely on the physical appearance of casts to make their guesses. Now, with DNA evidence, the story looks very different. Let's look at the case of the so-called family found in the House of the Golden Bracelet, which was discovered in 1974 on a Pompeii hillside. This group of 4 victims was named after an elaborate piece of jewelry was found on one of them. Based on the cast, one of the figures, who was holding a child, was assumed to be a mother. But the DNA results revealed this person was, in fact, a man. Even more surprising, none of the individuals were related, as scientists thought previously. Not surprising, given the extreme confusion and terror the people experienced as they desperately took shelter anywhere they could. Another interesting finding involves a pair of victims once thought to be sisters or a mother and daughter. DNA evidence now suggests that one of them was biologically male. Altogether, the researchers have analyzed the remains of 14 individuals for this study, and this is just a small portion of more than 1,000 victims of Mount Vesuvius's eruption that have been found so far. Archaeologists in Pompeii have also made one more discovery. Look at this figure. Initially, everyone believed that this man had been crushed by a massive boulder, a stone block that might have been part of a door frame during the eruption. His skull, with its mouth open as if in a final gasp, was found near his body. He was probably trying to escape all the chaos when it happened. But new evidence suggests that wasn't the case. His demise was likely the result of asphyxiation from a pyroclastic flow. For a long time, people thought Vesuvius erupted on August 24th. That's what some evidence seemed to suggest. But over the years, archaeologists started finding evidence that pointed to a later date. For example, they found graffiti dating back to late October and food remains, such as pomegranates. Such products wouldn't have been around in August yet. Plus, they found heating braziers in homes. Who would need extra heat in the summer of Italy? So, most experts agree that the eruption happened in late October. Now, it turns out that not everyone in Pompeii passed away. Scientists think that 15,000 people lived in the town, and only about 2,000 of them didn't survive the disaster. It means thousands of people managed to escape. But at the same time, their lives changed forever. They didn't have homes to come back to. Imagine fleeing your home with nothing but the clothes on your back, leaving behind everything you've ever known. Some survivors made it to nearby cities like Naples, but they had to start over from scratch. But recently, archaeologists made a pretty cool discovery: a fresco of a flatbread that might have been the ancient ancestor of pizza. Researchers found this painting in a house near a bakery. It shows a round bread sitting on a silver platter next to a goblet. They think people might have eaten this bread with fruits like pomegranates or dates, or maybe topped with spices or a kind of pesto. But the coolest part is that Pompeii is just 14 miles from Naples, which is the modern home of pizza. The director of Pompeii pointed out how this discovery connected a simple poor man's dish from ancient times to the modern pizza we all know and love. Today, Pompeii is one of the most famous archaeological sites in the world. Every year, new discoveries help us understand Roman life of those times even better. It's 9:59 a.m. when a man is jolted awake in his bed by a powerful, mysterious force. While he's trying to figure out what's going on, a giant 100-foot-tall column of water is already surging toward his hometown. In 20 minutes, most of his friends and family members will lose their lives when a sky-high wall of water sweeps away buildings, trees, and cars. And it can happen to you at any given time. It's the day after Christmas in 2004. Thousands of tourists from Europe and America are enjoying tropical beaches in Thailand, Sri Lanka, and Indonesia when a powerful undersea earthquake strikes off the western coast of northern Sumatra, Indonesia. It's a 9.3 magnitude earthquake, the most powerful ever recorded in Asia. It triggers one of the largest tsunamis in history, the Boxing Day tsunami, which will take the lives of 230,000 people within a few hours. The city of Banda Aceh in Sumatra, Indonesia, home to 260,000 people, is the closest to the earthquake's epicenter. In less than half an hour after the quake, huge 10-story tall waves crash into the city. More than 60,000 people lose their lives immediately. The destruction is so severe that almost no one in its path survives. Next, the tsunami hits Thailand. The waves, rushing at a mind-boggling 500 miles per hour across the Indian Ocean, reach the shores of Phang Nang and Phuket about 90 minutes later. Despite such a significant time gap, both locals and tourists are caught totally off guard. Many beachgoers even walk out onto the beach, curious about the strangely receding sea, only to be overtaken by a towering wall of water. Nearly 5,400 people, including 2,000 foreign tourists, won't survive that day in Thailand. An hour after Thailand, the tsunami hits southeastern India near Chennai. Debris-filled waves push miles inland, taking the lives of more than 10,000 people. Sri Lanka faces even worse devastation. The island will lose over 30,000 people, and hundreds of thousands will become homeless. The tsunami's incredible strength is evident even far away. 8 hours later, it claims its last victims in South Africa, 5,000 miles from the quake's epicenter. There, rogue waves catch swimmers off guard. Researchers from NOAA's Center for Tsunami Research explain that the destruction was due to the sheer power of the earthquake. It originated from a megathrust fault. That's where heavy ocean plates dive beneath lighter continental plates. These faults are the largest in the world and lie underwater. The 2004 earthquake ruptured a 900-mile stretch of the Indian and Australian plates, 31 miles beneath the seafloor. Plus, instead of one quick jolt, the quake lasted for 10 minutes and released an unimaginable amount of energy. During the shaking, massive sections of the seafloor moved upwards by 130 feet. That's a lot. Such a sudden movement set colossal waves rippling across the ocean. Imagine it like dropping a massive pebble into the water. The thing is, tsunami waves aren't like those surfing waves you may imagine. No, they look like a fast-moving whitewater river that floods everything in its way. If you get caught in those raging waters, it's almost impossible to survive. If the powerful currents don't pull you under, floating debris will. That's the reason why, during earthquakes, there are usually many injuries and fewer lives lost. With tsunamis, it's the opposite. There's way fewer injuries than fatalities because it's too hard to survive. Catastrophic tsunamis like the one in 2004 are rare. That's why India and Sri Lanka had no record of such disasters. This lack of experience, combined with the absence of warning systems, made the consequences of the disaster even more tragic. People didn't feel the earthquake because they were far from the epicenter. And with no natural warning signs, no official alerts, and no history of tsunamis, the waves that hit crowded coastlines had devastating effects. By the way, the Pacific Ocean, the largest ocean on Earth, is where most earthquakes and tsunamis occur. Locally damaging tsunamis strike somewhere in this ocean about once every 1 to 2 years. 76% of the recorded fatal tsunamis happened in the Pacific, and 99% of tsunami casualties are caused by local or regional tsunamis, which occur more often and hit quickly. But then a question arises: could a tsunami as devastating as the Boxing Day one happen again? Unfortunately, the answer isn't very straightforward. A warning system has indeed been established in the Indian Ocean. Its goal is to alert coastal nations of potential tsunamis. But human behavior is still a critical challenge. This became clear during a real-life test in 2012. That's when many residents of Banda Aceh, Indonesia, simply ignored evacuation towers after a tsunami warning. People never seem to learn, huh? The Indian Ocean Warning Network uses undersea pressure sensors placed near tectonic plate fault lines. These sensors detect any changes and transmit data to surface buoys, which then send it via satellite to control centers on land. Authorities analyze the information and decide whether to issue warnings and evacuate at-risk areas. Aceh, located on one of the world's most active fault lines, implemented additional safeguards. They installed sirens in coastal cities, and people get alerts on their cell phones. Plus, there are evacuation towers, reinforced concrete structures capable of holding 500 people. They are special safe zones. Authorities did test how well prepared people were. In 2009, 18 Indian Ocean countries participated in an evacuation drill, simulating a large earthquake. Thousands of coastal communities took part in this drill, and officials concluded that the exercise had been a success. Fast forward to the system's first real test in April 2012. An 8.6 magnitude undersea earthquake west of Aceh triggered tsunami warnings. And even though there were no significant waves, the whole situation revealed critical flaws. Many residents ignored evacuation towers, choosing instead to flee by car or motorbike. This led to citywide traffic jams, with people getting stranded in areas vulnerable to a potential tsunami. It was chaos. Some residents even went back to the beach to look for the signs of a tsunami, which is a life-threatening mistake. So apparently, there is still a lot of work to do when it comes to tsunami survival. But what you need to know by heart is the signs of an impending tsunami. First of all, it's severe ground shaking. Strong earthquakes near coastal areas can generate tsunamis. If you notice that water on the beach starts to recede at an alarming rate, exposing the ocean floor, reefs, and stranded fish, run. Then there might be unusual ocean sounds. Keep in mind that a loud roaring noise, resembling a train or jet engine, may accompany an approaching tsunami. If you notice any of these warning signs, do not wait for official evacuation orders. Leave low-lying coastal areas immediately and move to higher ground as fast as possible. If you're at home, make sure your family members know about the tsunami and follow official guidance. You should remember that locally generated tsunamis may strike within minutes. You have to act quickly. If it's a distant tsunami, you may have more time to evacuate. If you don't have an opportunity to move inland, hide in high reinforced concrete buildings. Avoid staying in small buildings or homes in low-lying areas. If you're on a boat, stay offshore. Tsunami activity isn't as dangerous in deep water, so avoid returning to port during a tsunami warning. If you're already in port, check with harbor authorities for guidance. If it's possible to move to deep water, do it in an orderly manner. It may be safer for small boat owners to leave their vessel and move to higher ground. And always, always prioritize moving to higher ground over saving your belongings. If you live in a coastal area, you can take some measures to protect your property in advance. Since most tsunami waves are under 10 feet, you may consider elevating your house. It can reduce damage. You can also consult an engineer to assess and reinforce your home. And finally, don't forget to protect outbuildings too, and create fences that will allow animals to reach higher ground. Around 2,500 years ago, an earthquake completely changed the course of one of the largest and most famous rivers on the planet, the Ganges. Now, it's normal for rivers not to sit in one place, so if you live next to one, it could also just disappear without a trace or flood the whole city one day. In the case of the Ganges River, a supermassive earthquake became the reason for this dramatic change. Scientists say it might happen again, and it would be a huge problem for millions of people who depend on this river. The Ganges River starts as small streams in the Himalayas and travels a long way, over 1,500 miles. Along its journey, it meets other big rivers before all the water flows into the Bay of Bengal. The Ganges has the largest delta in the world among all rivers. Just like many other rivers in the region, it slowly changes its path over time. These changes, if they happen when a river wears away its banks, usually takes a long time, sometimes decades. Scientists have discovered that the Ganges-Brahmaputra river system has shifted several times over the last 6,000 years. When they looked at satellite images of the Ganges Delta, they noticed something interesting. There was a crescent-shaped dip in the ground about 28 miles away from where the river is flowing now. This depression was over 1 mile wide and stretched for many miles. They thought it might have been an old main channel of the Ganges River a long time ago. In 2018, the team decided to visit the area to check it out for themselves and take samples to learn more about it. While driving back home, they noticed a pit where someone was digging dirt to create a pond. The next day, they planned to fill it with water, but the researchers spotted something strange in the dirt. There were vertical bands of light-colored sand mixed into the darker mud. These special layers are clues from the past. They show that an ancient earthquake made sand and water shoot up from below the ground and created sand volcanoes that were trapped in time. The scientists studied the sand and mud and figured out that these earthquakes happened around 2,500 years ago and were strong, with magnitudes of 7 to 8. The epicenter was over 110 miles away from the main stem of the river, but it was powerful enough to displace it. It could have affected around 140 million people. The Ganges-Brahmaputra system is close to spots where Earth's tectonic plates meet, so earthquakes happen here often. There's no danger right now, but scientists think that another massive earthquake could happen in the next few hundred or thousand years. It could threaten up to 170 million people. That's about half the population of the U.S. No one can predict exactly when an earthquake will happen or how strong it will be. Learning how earthquakes in the past moved rivers helps scientists figure out patterns and make guesses about similar events in the future. This knowledge could help us prepare better and create safety plans before another big earthquake strikes. Now, the Ganges isn't the only river at risk. The Yellow River, the Irrawaddy River, and rivers in the United States like the Klamath and San Joaquin all face similar dangers. The mighty Mississippi River has also switched its path many times over the last 7,000 years. Right now, there's a huge system of dams and barriers called a control structure in central Louisiana. This structure's job is to stop the Mississippi from spilling over its banks and joining a nearby river. But scientists think that, in theory, these barriers wouldn't handle mega floods. So the Mississippi could break free and change its course again. This would cause massive problems, especially in southern Louisiana. One of the recent examples when a river changing its course caused disaster was the Kosi River in India. In August 2008, over just a few days, the river's path shifted by almost 60 miles, which is a huge change. Floods happen in some parts of the state rather often, but they hadn't seen such strong ones in over 50 years. They affected around 1,000 villages and 3 million people, and about 1 million people had to be evacuated to safety. Since many of these people hadn't faced floods in so long, they weren't ready to handle it quickly. It caused even more damage to their homes and lives. Scientists have been trying for decades to figure out what exactly makes rivers suddenly change their course. A new study explains that two things work together to make a river to do it. This process is called avulsion. First, there's the setup, which is like building up tension before something big happens. Over time, sediment, sand, dirt, and other stuff carried by the river gets deposited in certain places. It either raises the river above the land around it or makes a nearby slope steeper than the river's current path. Then there's the trigger, which is like the final straw that makes everything happen. This trigger could be a big flood, an earthquake, or even something like a pile of logs blocking the water. Now, researchers looked at satellite images of about 170 cases of avulsion from the past 50 years. They noticed these events happen most often near river mouths and near mountains. Rivers were about 3 times more likely to change course in these places than in the areas between them. They also studied 58 river channels in detail, using super clear maps to measure super elevation. That's how high the river is compared to the land around it. They also measured slope advantage. That's how steep a new path might be compared to the river's current one. They found that near mountains, rivers often pile up so much sediment that they become super elevated and spill over. But near river mouths, like in deltas, rivers need a steep slope advantage to break through the mud and form a new path. These two factors work together like a seesaw. If one is stronger, the other doesn't need to be as strong for an avulsion to happen. To figure out where a river might go if it changes course, the researchers created a smart computer algorithm. This tool uses maps to measure the terrain's steepness and the river's flow to predict where the river might move. They tested it on 10 past avulsions, and it correctly guessed the path every single time. Scientists hope they could use these findings to protect people living near rivers from sudden floods. Rivers changing course played a big role in creating one of the first organized administration systems in the world. Scientists found clues for this in the territory of ancient Mesopotamia. This name means the land between two rivers, and it was between the rivers Tigris and the Euphrates. People living there relied on these rivers for water, food, and transportation. Scientists wanted to figure out how these sudden changes in these rivers affected ancient people. To do this, they used two kinds of maps. The archaeological maps show how ancient cities grew over time, including what types of buildings people built. Certain buildings, like big palaces or city walls, could show when each city first had an organized administration. The second kind of map showed where the Tigris and Euphrates rivers flowed long ago. They often shifted, sometimes slowly, and sometimes very quickly and dramatically. Around the year 5000 BCE, Mesopotamia started to become drier and farming became harder. Farmers had to grow their crops near rivers, where they could use the natural floods to water their fields or dig little channels to bring river water to their plants. Because farming was so important, towns and cities grew near the rivers too, so people could stay close to their food. But when a river suddenly changed its course, people didn't give up. They worked together to dig long canals to bring water from the new river path back to their fields. The canals helped them get water again, and the administration buildings showed they were organizing as a community to solve big problems together.
Back in the day, from 774 to 775, Earth got hit with a mega blast of radiation. This crazy burst of energy left its mark. 3 rings from that year show way too high levels of radioactive stuff. But what exactly caused it? Scientists are inclined to think that the reason was a solar flare. Some folks think maybe a massive supernova caused the radiation blast. But astronomer Phil Plait says that if that had been the case, it would have had to be less than 1,000 light years away and would have had been crazy bright. But there's no record of that happening. No bright, shiny Death Star in sight. After looking at the radioactive carbon and beryllium in tree rings, scientists ruled out a bunch of other possibilities. At first, they considered that it was a smash-up between neutron stars or a neutron star and a black hole. These types of crashes produce a super quick blast of gamma rays without any light show, which lines up best with the evidence. But these kinds of collisions are super rare. Plate thinks it's kinda unlikely that this is the answer. He figures we should only see one of these events in our galaxy about once every million years. So having one just 1,200 years ago seems pretty wild. Scientists are seriously worried about these rare events. If one happened closer to Earth, it could seriously mess up life on our planet. Even if it was thousands of light years away, a similar event today could cause chaos with all the fancy electronic systems we've come to rely on. So it's a good thing those gamma ray bursts are so rare, because if they were more common, Earth might be in for a rough ride. You may think that if our planet could withstand mega radiation blasts, it can easily withstand something less frightening. Let's say grasshoppers. Sorry to say that, but it's not exactly true. Back in 1874, during a hot summer in Kansas, things took a strange turn. Grasshoppers, or should I say locusts, invaded the Great Plains like nobody's business. They came down like a storm, blanketing houses, trees, and even poor trains passing by. These bugs were on a mission to cause chaos. Farmers had to scramble to protect their wells and just about anything else worth saving. Locusts landed everywhere, wreaking havoc on everything in sight. Even poor sheep lost their wool. Locusts even stripped paint off wagons and handles off pitchforks. This is how destructive they were. Livestock tried to fight back by eating them, but there were just too many of these insects. That year, those critters caused about $200 million in crop damage. The locust invasion was so tough, even the US Army stepped in to help. In the end, locusts began to disappear, sparing the plains from further devastation. Natural disasters can be even more unexpected than radiation blasts from space and locust invasions. Check this out. Back in June 2017, a reindeer herder up in northwest Siberia was minding their own business when they suddenly heard a crazy loud blast and saw smoke shooting up from the ground. If that happened to me, I'd need to change my pants. Sorry. Later on, they found this huge hole that was like 23 feet wide and nearly 65 feet deep and was surrounded by chunks of ice and dirt. It turned out that there were over 17 such black holes in the area. They were filled with peaty water and shrouded in mystery. Some folks thought those were sinkholes. Others were sure they were left by top-secret device tests or even a bunch of meteorites. Now, the latest idea is that these holes are actually craters caused by the Arctic warming up and melting the frozen ground. The theory states that as the ground thaws, gas pockets trapped beneath the surface burst through, creating such dramatic holes. Apparently, these eerie craters have been showing up in specific spots in Siberia where ancient geological faults have been leaking out hot natural gas for ages. Combine that with some leftover methane from old lake sediments, and you've got a recipe for some explosive surprises as the planet heats up. Not scared yet? Alright, maybe you're afraid of darkness, huh? If so, you wouldn't like it back in 536. It's the year when the world went through a crazy 18-month period of darkness. A mysterious fog covered Europe, the Middle East, and parts of Asia, blocking out the sun and causing chaos. It was like the Dark Ages, but for real. It turns out that the main culprit behind this fog was a volcanic eruption in Iceland. This eruption spread ash across the northern hemisphere, causing temperatures to drop and crops to fail. People were freezing and starving. It was a mess. Historians from back in the day even talked about how weird it was. The sun looked like the moon. Summers were freezing cold, and even China had summer snow. It was all because of the volcanic ash blocking out the sun. And to make things even worse, this period of darkness sparked the beginning of the bubonic plague in 541. Talk about a rough time to be alive. Let's go back to Siberia real quick. Back in 1908, way out in the wilds of Siberia, an asteroid dropped for an unexpected visit. Today, we know it as the Tunguska asteroid, but it didn't get its name instantly. Local folks only caught a glimpse of the show. A bright fireball streaking across the sky, followed by a massive boom. Trees went flying, fires blazed, and animals weren't too happy about it either. But since the area was so remote, not many folks took notice. For almost 2 decades, nobody bothered to check out the Tunguska site. People had too much on their plates back then. But then, scientists finally made it out there and found evidence of the asteroid's shenanigans. Later in expeditions, they found some spacey microparticles. Fast forward to now, and NASA has a whole planetary defense thing going on. They even sent a mission to test out asteroid deflecting tech. Because who knows when the next cosmic rock will come knocking on our door, right? In the middle of the 19th century, there was one more epic solar storm called the Carrington Event. It may not sound like a big deal to you, but it had pretty rough consequences. The next day after the storm, Earth was hit with this insane geomagnetic storm that threw telegraphs off the rails and brought auroras to the tropics. And it's the place where they normally never show up. Turns out, all this space weather madness started with weird stuff happening on the sun's surface, like sunspots. From these spots, solar flares and other crazy electromagnetic stuff can pop out and mess with our technology. Massive solar storms like this one can shoot out from the sun at speeds of up to 1,800 miles per second. They can contain billions of tons of solar material, complete with a sassy little magnetic field that loves to mess with Earth's magnetic field when they meet. Now, listen closely. We're getting close to the next solar maximum in 2025, so it's a good time to check out the history of the worst solar storms, like the Carrington Event, and take notice. Imagine if a similar storm hit today. An internet apocalypse, anyone? Businesses would be sent offline and we'd be facing some serious damages. Luckily, these mega solar storms don't happen very often. But hey, space weather is tricky to predict, so who knows when the next one will hit?
Seen a good horror movie lately? If you're a fan of those, then you can appreciate a good plot. But what if I told you that Mother Nature is the best scriptwriter ever? Ancient disasters were scarier than any horror movie today. From tsunamis to volcanic eruptions, you'll be shocked by the scale of these events. One natural disaster you definitely don't want to experience is a tsunami. Those gigantic walls of water sweep across the coast and take out everything in their way. And it's nothing new for our planet. Scientists were able to piece together a timeline based on evidence that major tsunamis left. In northern Chile, a large boulder sits high above the Pacific Ocean. Behind it, a desert as far as the eye can see. This 44-ton stone obviously doesn't belong here. It's the result of an ancient tsunami. Waves as high as a 6-story building carried boulders like pebbles. Researchers estimate this happened in 1420. But how can they possibly know this? In the 15th century, there were no written records in the region. Time for some detective work. Archaeologists discovered that around the same time, there was a tsunami in Japan, on the other side of the Pacific Ocean. The ground shook off the coast of Chile. That's how the tsunami was created. Then the wave traveled nearly 2/5 of the Earth's circumference. That's one tireless tsunami. But this wasn't a one-time event. Evidence suggests that a similar event happened 3,800 years ago. Ancient people abandoned their coastal villages around this time. They were moving inland. How did they know it was time to go? There's evidence of erosion due to strong currents, telltale signs of an ancient tsunami. As you know from school textbooks, oxygen is 21% of the air we breathe. But it wasn't always a part of Earth's atmosphere. Oxygen was missing during the first half of our planet's lifespan. Carbon dioxide and methane were the name of the game back then. CO2 is what makes our drinks fizz. But isn't the other gas dangerous? Yes, because you can't smell methane. And that's the reason there was no life on Earth billions of years ago. So how did we get from methane to oxygen? In come the cyanobacteria. This group of microbes started to evolve some 2.7 billion years ago. These tiny microbes mastered photosynthesis, converting sunlight into energy. And the byproduct of this process was, you've guessed it, oxygen. Soon it started escaping from water into the atmosphere. There, it reacted with methane, and over time, O2 replaced it completely. Scientists named this process the Great Oxidation Event. But how could it be bad? After all, we're alive thanks to it. All that oxygen acted as a poison for anaerobic organisms. And no, these are not life forms that didn't do aerobics or Pilates. The term simply means that these microorganisms didn't need oxygen to grow. Too much oxygen, and they would be goners. And that's precisely what happened. Scientists spoke of an oxygen overshoot that changed Earth's atmosphere for good. The disappearance of most anaerobic organisms was an early example of an extinction event. They didn't like the atmosphere at the time and decided to step down. But look on the bright side. They made room for oxygen-loving humans to enter the picture. Let's go to Turkey. No, not the seaside resorts that tourists visit in the summer, but the region of Anatolia in the southeast of the country. Göbekli Tepe is the world's oldest known temple site. It dates back to the Neolithic period. Scientists found a stone pillar here that tells a tale of an ancient disaster. They presume that the pillar is commemorative. Today, humans still build similar structures to mark an important event or a person. Just one example is the Washington Memorial. It was built in honor of the first American president, George Washington. But the pillar in Turkey doesn't commemorate a happy event. Scientists believe it shows a devastating occurrence, a comet crashing into the Earth. The event must have been destructive. There are also other signs on the monument. These symbols align with the setup of the night sky stars for the year 10,950 BCE. The date astounded the researchers. It matched their earlier research of an ice core sample in Greenland. This showed that a comet fragment hit our planet around the same time. The archaeological site could have easily been an ancient observatory. And whoever worked at it observed a cataclysmic event. The impact must have been so powerful that it changed the Earth's rotational axis. That's the imaginary pole going through our planet from top to bottom. That ancient comet must have packed a punch to knock the blue planet off balance. Have you heard of the city of Tal El Hammam in the valley of the Jordan River? The reason why your answer is probably no is that the city doesn't exist today. It completely disappeared around the year 1650 BCE. It was one of the three major cities in this part of the Middle East. Together, these three cities had a population bigger than Palm Springs today. At the time, Tal El Hammam was a metropolis. It even had high-rises, 5-story buildings constructed using mud bricks. But archaeologists found strange markings on them. The bricks melted as they were exposed to high temperatures. Yes, sound the fire alarm. Some sort of disaster had caused a major fire. Archaeological finds pointed to a suspect for such damage, a rock from space. So, where was the crater? This comet, or an asteroid, never made it to the ground. It was traveling at high speed, so it disintegrated before hitting the ground. Such an event is called an airburst. The largest witnessed meteor airburst happened over Tunguska in the north of Asia in 1908. Scientists estimated that the airburst in Tal El Hammam happened 2.5 miles above the city. This event released a lot of energy. Air temperature quickly rose to 3,600 degrees Fahrenheit. That's hot enough to set clothes and wood on fire in an instant. Mud bricks and tools made from metal start to melt when exposed to such heat. This would explain the evidence scientists unearthed. But there was one more find: salt. The event was so powerful that it distributed salt over the region around the Dead Sea. Any farmer will tell you that salty soil and crops don't go well together. People started moving away from the area because they couldn't grow food. Imagine an island with whitewashed villages surrounded by a sapphire blue sea. Such a place exists in reality. It's the island of Santorini. But the history of this place hides a tale of destruction. The island is of volcanic origin. This means that a violent eruption created it some 3,000 years ago. Now there are two islands. The bigger one is shaped like a horseshoe. When you look at them from above, the two islands look like they form a circle. That's because they were once a single island. It had a large mountain and was round in shape. But then it all changed almost overnight. One of the largest volcanic eruptions in human history tore Santorini apart. The earth trembled, tsunamis formed, and clouds of ash filled the sky. A daunting image. People felt the eruption hundreds of miles away. When it was all over, seawater rushed into the caldera of the former volcano. That's why the water in the lagoon has such a beautiful color. Scientists know so much about Santorini's past because of an unlikely assistant, a tree. The juniper tree, to be exact. People use its aromatic wood for everything from furniture to making pencils. On the Greek island, its rings revealed the tale of the ancient eruption. As a tree grows, it doesn't only go up, it expands sideways as well. Each new layer of bark adds a ring to the trunk. It takes a year for one ring to form. And on Santorini, one ring was unnaturally pale. The scientists did the math and voila, they dated the eruption to 1560 BCE.
Floods, tornadoes, tsunamis, hurricanes, yikes. All these natural disasters can get extremely dangerous, but we're kind of familiar with them. But how about a natural disaster that has never happened before, but could occur any moment now? It might be a super eruption. That's what happens when a supervolcano erupts. You might know that Yellowstone Park is located on top of a supervolcano. The last massive eruption there happened about 664,000 years ago, and the one before that, approximately 1.3 million years ago. If we do the math, we'll understand that the next eruption might be due anytime soon. There's no strong evidence that the supervolcano is waking up or preparing for an eruption, but what would it be like if it did happen? Months before the eruption, small-scale earthquakes would become more frequent and more powerful in the area. Not long before the eruption, the growing pressure would push up the ground over the volcano, creating a dome. Narrow cracks would open along the edges of this dome. The magma would then start rising toward the surface, and then the eruption would kick off. A massive column of lava and ash would shoot up into the air to a height of over 16 miles. The volcano would keep pumping ash for days on end. The air in that area would heat up to 570 degrees Fahrenheit. For all living creatures, ash fallout would be one of the most dangerous consequences of the eruption. Buildings and trees would start collapsing under the weight of this dense substance. It would only take a couple of days for a 10-foot layer of ash to cover the territory of about 50 miles around the center of the eruption. After the ash got into the stratosphere, the temperatures all over the world would start to drop. The eruption would also be rich in sulfur, and this element is an effective sun blocker. That's why it would soon get so cold that there would be no summer in the whole world for the next several years. The monsoon seasons would change. It would be hard for animals to find food and clean water. Well now, how about a gamma ray burst? You don't stumble across this kind of radiation in your everyday life. A gamma ray burst occurs when two neutron stars collide. The collapse of a massive star can produce it too. Gamma rays could present a serious danger to Earth. If a gamma ray burst happened close to our home planet, it could rip our ozone layer away. After that, we would be left unprotected from the sun's ultraviolet radiation. Plus, gamma rays could also produce ground ozone. This kind of ozone could seep into the ocean since it's water-soluble, and that would lead to a mass extinction of marine life. Plants wouldn't survive this disaster either. Now, come to think of it, giant sinkholes could swallow entire communities. One of such sinkholes opened up in the city of New York. It pulled a parked van into the earth. That happened in the summer of 2022. And it wasn't the only sinkhole to appear in that area. Local inhabitants reported about 4,000 sinkholes all over the city. This kind of problem is also very common in Florida, and it's much more serious than it may sound. Sinkholes open all of a sudden, pulling down everything and everyone that happens to be nearby. Sinkholes appear all over the world, which makes them a global problem. They're totally unpredictable and form without warning. Luckily, experts know what causes them. In some areas, there are vast areas of groundwater. But during droughts, this water dries up. This creates large empty caverns, and after heavy rains, the surface over such a cavern can collapse, creating a sinkhole within minutes. Now, what if we came across a wandering black hole? You might know that a black hole is a region in space where gravity is so powerful that not even light can escape its clutches. Luckily, the nearest one to us is 1,500 light-years away. Nothing to worry about, right? Until you find out about wandering black holes. Now, things get definitely way creepier. If such a black hole entered the solar system, Earth would be doomed. We wouldn't stand a chance against this space monster. In 2012, 13 wandering black holes were spotted not so far away from our planet. But worry not. Not far away, in space terms, means around 1 billion light-years away. So we've got some time left. Plus, the possibility of such a disaster is very, very low. Another natural disaster we haven't experienced yet is a mega flood. It's never happened before, but the changes in climate do make for a risky potential. It could start, let's say, in California. This state experienced some really bad flooding in the past. One of such floods stretched up to 60 miles across and 300 miles long. If a similar disaster happened these days, it would cause $1 trillion worth of damage. It would also uproot millions of people. Now let's talk about a hypercane. Judging from the name, this natural disaster might get extreme. A hypercane is a theoretical hurricane of unsurpassed power. It would occur if the ocean became overheated as a result of climate change, or because of a massive volcanic eruption. In any case, these conditions could create a hurricane that would stretch way beyond the lower stratosphere. And as you may guess, regular hurricanes don't do that. The hypercane speed would reach 500 miles per hour. The pressure inside would be low enough not to let the hypercane to wear out as quickly as other hurricanes. The hypercane could last for weeks on end. But the worst thing? It could damage or even destroy part of Earth's ozone layer, and the hole could be the size of the entire North American continent. Now, this disaster did happen before. About 66 million years ago. I bet you know what I'm hinting at. Yep, that very meteor that supposedly wiped out dinosaurs off the face of the Earth. This 7-mile-wide space visitor was traveling at 67,000 miles per hour. As a result of the collision, 75% of all life on the planet disappeared, and winter reigned on Earth for 18 months. Want to know a secret? Meteors strike Earth all the time. Even more of them barely miss our planet. But it's also very hard to predict meteor strikes. Scientists miss a lot of them until they just nearly miss us. That's why experts are working on an early warning system that could prevent disasters. It could make meteor impacts less catastrophic, or at least allow people time to evacuate. It could also be our very own sun that would be responsible for another natural disaster. I'm talking about a massive solar flare. On the scale of damage to society, few catastrophes can compare to this event. It wouldn't destroy buildings like a tsunami or an earthquake. Neither would it end lives in the same way a supervolcano or meteor would. But it would cripple our entire way of life by destroying the whole electronic infrastructure of Earth. The cost of this disaster would reach trillions of dollars. It'd cause other infrastructures to fail: communication, medicine, transportation, banking systems. Those would tumble like dominoes, and it would be incredibly hard to recover them. Earth would be left without electricity for years. There would be no electric light, no computers, no phones. Water supply systems would be out of order. There would be no food in supermarkets. There would be no electricity, and people wouldn't be able to reboot the already broken power grids. In 1859, people all over the world woke up in the middle of the night. It was as light as during the day. The skies were illuminated with auroras, red, green, purple. They appeared even in the regions where no one had seen them before, like the Bahamas, Jamaica, or Hawaii. Telegraphs got electrically charged, even though they were disconnected. In many areas, fires started. That was when technology barely existed. But imagine the avalanche of problems a solar flare could cause today. Rocks rolling down the slopes of a rumbling volcano, pushing other bigger rocks on their way, and eventually tumbling down into the ocean in a humongous cascade, causing a wave the height of which the world's never seen before. This is what might happen if the Helena slump of the Hawaiian Big Island falls off into the water. The Kilauea volcano is far from dormant. The latest eruption occurred in 2018. Its eruptions are usually accompanied by earthquakes of different magnitudes, and with each quake, the magma rocks on the slopes of the volcano shift down. These rock formations are called slumps, and the Helena slump is the most notorious of them all. In 1868, the shift of this slump caused a tidal wave rising as tall as 60 feet. But what's most troubling is that some 110,000 years ago, a landslide here led to one of the most powerful earthquakes ever, which in turn led to a mega tsunami of over 1,000 feet in height. Scientists are worried that such an event may repeat in the future. If that happens, the wave might engulf the whole of Hawaii and easily reach both North and South American coasts. Geologists are quick to reassure, though, that a landslide like this is unlikely to occur anytime soon. It's just too early for that. But when it finally does, the consequences will be catastrophic. Have a nice day! Yellowstone National Park in the western USA is world famous for its dazzling views, and especially the colorful Grand Prismatic Spring at its very heart. But we should all stay aware that Yellowstone is, first and foremost, an enormous caldera, basically a slumbering supervolcano. The difference between a regular volcano, like Kilauea from earlier, and a supervolcano is that the latter is thousands of times more powerful. Imagine an eruption spewing tons of huge rock and rivers of hot lava, pumping out clouds of ash that make countries stop air travel for weeks. And now multiply all of this by 1,000. This is what a Yellowstone eruption would look like. At first, a huge area in the middle of the national park would shake, crumble, and then blast upwards in a megaton explosion. Lava flows and magma rocks would cover the area of about 40 square miles, roughly half of Washington, D.C. But the greatest danger is the volcanic ash. The ashen plume would rise miles above and get carried by the wind in every direction. Since the eruption would be far from ordinary, the spread and damage would also be much greater than usual. The ash is thick and heavy, so it would cover a vast area in a blanket, destroying crops and even buildings. Worse still, it would spread in the air and block out the sun, leading to a drastic drop in temperature and an artificial winter. Even regular volcanoes can lower temperatures worldwide by a few degrees. A supervolcano may potentially cause a new ice age. Luckily, the chances of Yellowstone supervolcano erupting in the near future, or at all, are extremely low. There have been only 3 of those in the history of Earth, and there's no evidence such a disaster should repeat. Scientists estimate the probability at 0.00014%, which is lower than the chances of an asteroid wiping us all out. Speaking of which, if dinosaurs could talk, and were at least still alive for that matter, they'd tell you that asteroid threat is as real as it gets. Scientists at NASA say they've tracked 90% of all near-Earth asteroids of significant size, and none of them are a matter of any concern. But there are still the other 10% in the great unknown. What's more, asteroids can change their line of flight because of the pull of other celestial bodies and eventually turn our way. Lucky us. Now, if an asteroid big enough, like a mile across, hits the Earth, it will first cause an explosion powerful enough to erase a dozen big cities in a matter of seconds. Then the impact will raise a cloud of dust and debris that will block out the sun, just like the ash cloud from a volcano, and cause a centuries-long winter on the whole planet. But even if it falls into the ocean, which is more likely, a resulting wave will rise several miles high, washing coastal cities off the face of the planet. But at least there won't be a new ice age. Although scientists are pretty sure there's no such threat in the near future, it can't be ruled out completely, and humanity needs at least 5 years to prepare for this event. If a big near-Earth asteroid suddenly changes its course and turns right toward our planet, we won't stand a chance against it. Disaster movie, anyone? A much more probable calamity, though, rests right beneath our feet. It's the San Andreas Fault in California. The fault has been ready for rupture for years now, and scientists estimate that an earthquake along this line is likely to occur in the next 3 decades. And when it happens, it won't be nice. They expect a magnitude of 8.0, which is comparable to some of the most devastating quakes in history. It's all the more dangerous since California is home to some of the most populated cities in the western U.S., including Los Angeles and San Francisco. High-rise buildings are common there, and they're particularly vulnerable against underground shakes. The San Andreas earthquake might cause a whole lot of damage both to cities and countryside. In the worst-case scenario, the ground might break apart, destroying buildings, farms, and changing the landscape altogether. Still, scientists believe that the probability of such a quake is only 7% for the next 30 years. So there's a rather big chance, 93%, that we'll never see that in our lifetime. Yet, there's another earthquake hazard not so far away from the previous one: the megathrust in Chile. The country sits right above the subduction zone, an area where 2 tectonic plates meet and go one beneath the other. At the place of their meeting, stress has accumulated because of their continuous movement, and once that strain is too much, a major earthquake occurs. Chile has experienced a lot of quakes in the recent years, and scientists are worried those might be preparing the area for a really big one. They believe a great earthquake is due to happen before the end of the century, and it might be devastating to the coastal area. Even smaller quakes cause tsunamis that flooded the west coast, and a huge one like that is likely to raise a wave of incredible height. On the bright side, Chile now knows to prepare in advance for the coming natural disasters, and geologists are pretty sure people will be able to evacuate before the earthquake strikes. In September of 1859, astronomer Richard Carrington was looking at the sun and suddenly saw a bright flare on its surface. He made a note of it in his records, but only realized how important it was a couple of days later. The energy from that flare reached Earth and struck it directly, causing northern lights to appear above Cuba and burning telegraph lines all around the world. This was dubbed the Carrington event, and it was a solar storm. Such storms hit the Earth fairly often, but none of them were so powerful as the Carrington event, neither before nor after. But in 2012, astronomers registered a similar solar flare whose energy nearly hit our planet once again. If it had been just a week earlier, we'd have been in big trouble. Today, humanity relies on electricity in almost every aspect of life, and a powerful solar storm would mess with the electromagnetic field of Earth a lot. All electric appliances would either shut down or short-circuit, and huge transformers powering basically everything would go out of order for good. It would take years to repair them, and the cost of such a massive blackout would count in trillions of dollars. The worst of it is that science is almost unable to predict solar storms. And even if we could know about them in advance, we'd be powerless to stop them. The flare happens in a matter of seconds, and it takes about 8 minutes for the particles to reach the Earth's atmosphere, causing the disturbance. The power outage would come a bit later, in a day or so, when a massive cloud of plasma gets to our planet. At the moment, there's no protection against solar flares, and the chances of one powerful enough to cut all of our electricity in the next few years are quite high, about 12%. The only good thing about all this is that we now know of such a possibility and can at least prepare in advance. Hey, don't forget to pack some underwear and socks. You'll always need those.
There used to be a real oasis in the desert along the border between Kazakhstan and Uzbekistan. It was once the fourth largest lake in the world by area, 2 times as big as the entire country of Belgium. For thousands of years, it was home to freshwater fish and fed thousands of families who worked in the fishing industry. I'm talking about the Aral Sea. And now, it's all gone. Not dried a little bit, gone. The water retreated so far that ships now sit stranded in deserts, and their rusting hulls are half buried in sand. Villages that once relied on fishing now choke on dust storms made of salt and pesticide residue. It's like someone took the sea, crumpled it up, and tossed it into history. The worst part is that this wasn't a drought or some natural climate shift. This was all us humans. The land around the Aral Sea was always dry and harsh, but the sea held everything together. 2 great rivers fed it, and as long as they flowed freely, the Aral stayed steady. But then in the 1960s, the officials with big plans and even bigger ambitions decided to turn deserts into farmland and prove that human will could reshape nature itself. Engineers began siphoning water from both rivers for massive irrigation projects. By the time farmers were watering their parched fields, the Aral Sea was already bleeding out. Each canal carved from the rivers was like another cut. The flow weakened, the summers got hotter, and the water disappeared faster than anyone expected. And here's the tragic punchline. Those grand irrigation systems didn't even work properly. Somewhere between 25% and 75% of all the diverted water didn't reach the crops at all and just evaporated into thin air before it ever hit the soil. By the 1980s, both rivers were drying up completely in the hottest months. The Aral Sea's balance shattered, the water levels plummeted, and what remained became too salty for fish to survive. The once bustling fishing communities were wiped off the map. Within just 30 years, the massive inland lake had split into 2. In the early 2000s, Kazakhstan decided to fight back, or at least save what was left. They built the Koch-Aral Dike and Dam to trap the remaining water in the northern basin instead of letting it flow south and vanish. The northern part of the Aral Sea started to refill. Fish began to return, but the victory was only partial. To the south and east, the vast basin that once teemed with water and life kept fading away. By 2014, satellite images showed the eastern part completely dry, gone. For the first time in 600 years, the Aral Sea ceased to exist as a true sea. The salt from the exposed seabed of the Aral Sea poisoned farmland for miles, ruined water supplies, and spread lung and kidney disease across entire regions. The fishing towns lost everything, and that is the story we keep repeating. Over and over. We push, but then nature pushes back, even harder. There's another body of water with a tragic story a few thousand miles away. Lake Chad in Central Africa. Once, it was one of the largest lakes on Earth. Fishermen crossed it by boat. Herders watered their animals and entire economies depended on it. But it has shrunk by around 90% since the 1960s. How did it happen? Same pattern. Humans diverted its inflowing rivers for farming and irrigation. Again, for crops meant to make money fast. Combine that with some changes in climate conditions and a few decades of bad management, and poof. A lake the size of the entire country of Rwanda turned into cracked mudflats. The tragedy doesn't end with the water. When the lake vanished, livelihoods went with it. People started fighting over what was left. grazing land, wells, fish, and that tension helped fuel conflicts between 30 million people living in the region. Now, let's jump to 2023. You might have seen it in the news for a day or two, but then it vanished from the headlines. The city of Derna, Libya is gone, washed away. There were 2 dams upstream from the city, both built in the 1970s. They were meant to control floods, back when people still maintained them. But then came years of conflicts, corruption, and neglect. Engineers knew that the dams were cracked, but nobody fixed them. Then, Storm Daniel hit. It was a monster of a storm, supercharged by a warming Mediterranean. The rain poured for hours, the reservoirs filled up, and those neglected dams just gave up. 2 walls of water went roaring through the valley in the middle of the night. It tore through Derna like a super powerful bulldozer. Entire neighborhoods were swept into the sea, and more than 10,000 people vanished in a single night. And probably the saddest part is that everyone knew this could happen. It was just a matter of when. If that sounds creepy and tragic, how about a horror movie set in real life? This is Centralia, Pennsylvania. Population 0, or close enough. It used to be a bustling coal town full of miners, families, diners, and little brick houses. Then one day in 1962, as the main theory says, someone decided to burn trash in an old pit. Nothing unusual, except that pit connected to a maze of coal tunnels underground. The fire spread down into the mines and it never stopped burning. Let me say that again. It's still burning. The ground itself is on fire. You can walk through Centralia today and see steam seeping out of cracks in the road, and the air is hot and metallic. The ground is unstable and it can just open up and swallow you. The authorities bought out the town in the 1980s, evacuated everyone, and bulldozed the houses. And yet, all of this was preventable. If anyone had sealed the mine shafts properly, monitored gas levels, or just taken the risk seriously, Centralia might still exist. Instead, it's a ghost town on fire, a literal warning that we don't always need nature to burn us. We can do it ourselves just fine. Another crazy thing humans have mastered is starting earthquakes. If you don't trust me, meet Pawnee, Oklahoma. On September 3, 2016, at 7:02 a.m., a 5.8 magnitude earthquake hit. The strongest ever recorded in the state. People's walls cracked, furniture toppled, and for a moment, Oklahoma felt like California. But Oklahoma isn't supposed to have earthquakes that big. So, what happened? The answer lies underground, in the wastewater disposal wells from fracking operations. When companies extract oil and gas using hydraulic fracturing, they pump millions of gallons of water and chemicals deep into the ground. The leftover fluid, contaminated and pressurized, has to go somewhere, so they inject it into deep wells. Those injections increase pressure along old fault lines and eventually snap. The Earth literally moves. It's not like anyone was surprised either. Scientists warned about it for years. Oklahoma went from averaging 2 noticeable earthquakes a year to more than 900 by 2015. And yet, permits for new wells kept rolling in. If there's one thread through all these stories, it's this. Every disaster had a warning label. The RLC didn't dry up overnight. Derna's dams didn't crack in secret. Centralia's fires started with a match we lit. We saw it coming. We just didn't want to stop. And have you noticed how fire season doesn't really end anymore? California, Australia, Greece, take your pick. Wildfires are bigger, faster, and harder to stop every year. And no, it's not just the weather. Take a century of deforestation, mix in sprawling suburbs built right next to forests, and top it off with electrical lines and dry grass. You get a firestorm waiting for a spark, and that spark is usually human too. While some places are on fire, others are sinking, literally. In places like Indonesia, overpumping groundwater for cities and industries is making entire coastal areas sink. Jakarta, for example, is going down so fast it might become uninhabitable in a few decades. And yet, new buildings keep going up. Maybe it's greed. Maybe it's short-term thinking. Maybe we just believe nature will keep forgiving us. But one day, we'll realize forgiveness isn't infinite.